Oh, stop. Hello, I'm trying to make a grand entrance today. Welcome to Coding Rainbow, episode 48. I've typically had a problem where the sound isn't working correctly when I first started the last couple times. So please immediately in the chat, if you could let me know, is there any static, clipping? I'm playing some music. Can you hear the music? In addition to seeing me talk and hearing me talk. Hopefully that's working okay. Welcome. I have a bunch of things I'd like to discuss. This is episode 48. I'm live from the School for Poetic Computation here in the West Village of New York City. Sounds good. Thank you very much. And okay, so let's turn the music off for a second. So first of all, if you're watching this in the archive, go and check the video description. There'll be links to time codes of where various things happen. But I'm a little bit flummoxed and flustered because today what I want to do, and it's been requested, and I wanted to spend most of today talking about and looking at different examples around the larger topic of computer vision. I have this camera that I found here. It is a Sony PlayStation Eye camera, and you know, I used this. This is probably like 5 years ago at this point, but I used to use this with processing on my Mac all the time, and it was good for an external webcam. It doesn't really work so much anymore. So I have a weird sort of like hacky way that I might try to get it to work. And you might be asking, why? Why do you want to use that camera anyway? You've got this thing. I'm going to go here, right? I have a webcam right there. There I am. Look, it's me. Look at this. A little behind the scenes going on right now. You're seeing this live composite, but really what I am is a person standing in front of a green screen, and then I'm putting my computer screen behind me. Anyway, you get the idea. But the point is, I could use this to demonstrate. I want a live camera feed to demonstrate some computer vision ideas and topics. But what I was hoping to do was take this camera here. I don't know what I'm looking at anymore, and tape it right here and point it down at the table because I have these cups. Ooh, maybe these would be good for juggling. No, not so good for juggling. I have these cups. I have these cups, and I was going to use these as things for the camera to look at and move them around and show you how to and talk about blob detection with these as being so to make a kind of interactive tabletop type thing. But I couldn't get that camera to work. So I think what I'm going to do today is, luckily, it just so happens I happen to have this green screen here. So I can actually move my laptop over to here and point the camera, and I have this really nice clean image. So one of the things you want in it with working with computer vision applications, the types of things that you might do is to create a really, for a lot of the demonstrations I want to show you, having a high contrast image, something with a very different foreground and background. And so, oh, look at this. Watch this. I have a weird idea. This is the problem. I'm not looking at you, because you're the one watching. And I have a piece of tape here. This is going to be excellent. There we go. Now we're going to use this for blob detection. So one of the things that I want to do today, I'm standing in front of it, is, whoa, look at this. Which is the real cup? Is this the real cup? Or is this my mind is exploding. It's freakish. Everywhere I look, there's a screen or a camera or some copy of me, and I'm just take a deep breath, put my music back on. Okay, I think everything's starting to feel a little better and a little more calm. I'm not walked into it. Okay, so one of the things I want to talk about today is blob detection. And what do I mean by blob detection? I mean, how can I have a camera, a computer? Computer vision, by the way, this idea of computer vision, the computer that sees, how do we write algorithms for the computer to be able to look at an image and analyze that image and produce some sort of result, some evaluation of that image? And that can be a lot of things, from I think there's a person there, or I actually recognize that this is a landscape scene of a beach. All sorts of machine learning type kind of things. But I want to start from the very basics, and we could say like, okay, what colors am I seeing? Me, the camera. I'm seeing green and I'm seeing red. Where are the red colors? They're over there. Is there a lot of red? Is there a little bit of red? That sort of thing. So I want to start to look at that type of stuff. Okay, so that's kind of one of the main topics today. The other thing is, I gotta close this. Let me see if I can find this. I'm going to open up processing. I am going to, so let's see, it's about 11:30 a.m. Eastern time right now. And I am going to find an example. I should have prepared. Processing, maybe here, fireworks. It's not here. Oh, you know, I probably already put it. Maybe I put it on the desktop here. No. I want to find something. Hold on. You need to listen to some music while I'm looking. Ooh, no. Hold on, everybody. Okay, I'm searching for something now. Enjoy the music. Need to get some more Creative Commons music. Oh, I know where it is. I know where it is. Time out. I know where it is. I forgot where I put it. Okay. Okay. So I want to do a coding challenge today since it's the July 4th holiday coming up. Fireworks in here are these United States where I am currently. And so this is kind of one of these, I guess I should turn the music off maybe. Oh, it stopped anyway. This is one of these sort of classic computational visualization algorithm-y things. You know, when you first start learning creative code and graphics and programming, you think, hey, let's make a firework simulation, and there's particles and a little physics and some stuff there. So I want to do this today before I leave here. So let's say this is going to be about a 2-hour session. I'm going to spend an hour and a half or so on various computer vision topics, and then when there's a half an hour left, I will stop and do this coding challenge, and I will also happily take your questions. Okay. So in a moment, I'm going to start with the computer vision stuff. Before I get to that, let me just say a few words again. If you are new here, I'm going to mention that if you're wondering what this is, you can go to codingrainbow.com. What I'm doing now is a kind of raw, unfiltered, rambling discussion of creative coding topics. I will program things and talk about things and watch this YouTube chat and answer questions. And once this is done, I will take the sort of cogent chunks of video from this 2-hour plus session and edit those into tutorial videos. Those will appear on my YouTube channel. So if you want to get notifications of those, you can subscribe on YouTube. I also am running something called a Patreon, which is a kind of crowdfunding for media content, podcasts, videos, other types of things too. And so you're welcome to consider joining that. For joining that, there is a Slack channel that you then get invited to where I discuss topics I'm going to do and answer questions and that sort of thing. A nice community of folks. And then the last thing is if you want to know when I'm going to be doing live streams, you can scroll down and put your email in here and I will send out emails. As those of you who are on this list notice, I send out an email like 15 minutes beforehand, but sometimes I'm better about scheduling and I'll tell you a day in advance or 2 days in advance, that sort of thing. So this will be my last Coding Rainbow session for this week. I'm traveling next week, so there won't be any live session. I am personally committed with this sort of Patreon thing that I'm doing to doing 4 sessions per month, which is once per week. I have been getting more. I would say I'm right now I'm operating on like 6 or 7 per month, so I'm kind of exceeding that. But since I'm missing next week, certainly the week after, I'm going to make sure I schedule to do 2 live sessions so that I've caught up there. And that's kind of my plan. One of the reasons for doing the Patreon is to give me a little, what's the word I'm looking for? It's to give me some sort of like obligation, so to speak, so I feel that I'm kind of making sure I'm doing it. Neon Cat Fan asks in the chat if anyone has backed Pebble 2. This, by the way, is a Pebble watch. I don't mean to be buzz marketing Pebble by accident. I like it just fine. Take it or leave it. But I'm thinking of getting a Pebble 2. Okay, so I'm going to start getting myself set up to talk about some of these computer vision topics. If you have some questions before I get started, ask in the chat. So two things I want to do. Let's put on some music again. So I'm going to get a few things open here that I'm going to reference. Okay, you can see all my looking around to try to get that PSI to work. Okay, it ended yesterday. Okay, I'm looking for now. I'm going to find my playlist. Okay. Now, let me see here. No, this is just me. This is, by the way, as if I'm not live streaming right now. This is what I would be doing by myself. And I'd like lose my chance. Okay, I'm looking for something. Hold on. I'm starting. There's an example that I want to start with, and so I just want to pull it up. LP. There we go. Learning, processing, video, color track is where I'm. Okay, want to know something quite amusing here, which is that I'm using something called Cam Twist. I forgot that I had that running. Okay, I'm going to turn that off. So I'm going to talk about Cam Twist in a minute. This was my secret way of maybe getting the PSI to work. Seriously? Oh, that's why. No? Sorry, everyone. Hold on. I am trying to figure out why my computer is doing Cam Twist only. I might just need to restart. Oh, boy. Really wants to do Cam Twist badly. All right, I'm going to restart this computer. Hold on. Save as computer vision 1. Hold on, this computer is going to restart. Oh, look, the empty void of nothingness. Please restart sooner than later. Oh, look. Oh, did you hear that sound? Did the bong sound actually make its way through to the stream? Okay, so sorry, this is not going very well so far. Okay, let me log back in. See if I can get rid of this Cam Twist thing that happened by accident. I'm going to open up processing. So. Open recent, computer vision, come, Come. Let's see. I guess I have to uninstall CamTwist. I should not have installed it. I killed my computer by installing CamTwist. Okay, boy, this is a big failure today. Okay, let's see. How do I... hold on, I'm thinking. Probably installed some drivers. I have... What's that thing called that I have? Clean my Mac. Okay, sorry. Stop with this. I was just going to use this. I have this software that will automatically uninstall things nicely, but instead, uninstaller. I want to install CamTwist. Here we go. Uninstall. Sorry, everybody. This is really not going very well today. Okay, let's see if that helps. I might need to restart again. CamTwist. Oh my God, it's crazy. Let's try restarting one more time. Now that I at least did that uninstall. I might have to I could switch to using a different computer. Actually, I have a whole, there's lots of things I could do actually. Which I might in a second. Take some more, anyway, so just to while I'm kind of getting started here, what's this over here that's you're seeing? There's something, oh, this, it's a T. Okay. Okay, let's see now. I'm hoping this is going to be the moment. Usually I do this kind of stuff. I say usually I do this kind of stuff beforehand, and I say that just because I aspire to do this beforehand. And I had done a lot of this beforehand. Okay, I'm going to take more drastic measures. What I'm going to do is create a new 50 people are watching this total disaster. By the way, this has happened to be in real life class. This is actually real life class too. Okay. Gosh. Let's make a new user. Let's see if I make a new user. Coding rainbow. Create user. That's fine. I don't want a password. I want this user to be an administrator. And I want to log out. Ooh, look at this. Coding Rainbow is a parrot. I'm hoping. Don't sign in. Definitely not. Yes, skip. Oh. Ooh. Oh, I feel so like I'm in the mountains. All right, thank you. Okay, let's quickly, I'm going to do something silly, which is I think I'm actually just going to be fastest here to download, processing. I think this will actually be yeah, it is true that one of the big issues here is that I'm using a Mac. Okay, let's come here, take this, move this to the desktop. And and I'm opening processing. I hope this isn't anybody's first time watching. I don't need this message. Now I'm going to add a library, and I'm going to add a video. And it's going to install that. Oh boy, has this really been going for a half an hour that the camera's about to shut off? That's bad. Okay, now examples, libraries, video, let's go to capture, let's go to getting started capture, and let's hit play, and let's, Cam Twist has taken over everywhere. This is crazy. Okay. Oh, but look, I am back here. Okay, so at least I thought I saw some. Yeah, look, Cam Twist is still there. Oh, and all right, hold on. Let's just try one more thing here. I think I'm going to be back in a second. I have some good, for all of you who think this is like total, complete failure today, I do have some good news. I purchased some fresh whiteboard markers. Okay, now I have a feeling that back here at least, if I go to video, capture, getting started capture, and run this, we're back. Okay, there's an unfortunate reality here, which is that I think I've done so many weird things that it now takes like 5 minutes for the program to start. I'm tempted actually to do these examples in JavaScript, just in the browser. Okay, so at least I have the camera working, and I have a feeling that the Cam Twist thing, which is really irritating me, I might install that back later. It's just, I think that maybe I just need to do this. Open recent, computer vision 1. Let's try this. Oh, sorry. Oops. Okay, hold on. We're getting there. Okay. I've got something going now. All right, I've got something we can work with here. So it's just frustrating me that all these like horrible error messages are all because I installed that Cam Twist thing, and I really wish I could get rid of it because it's messing with what it is that I want to do. And I want to see, I want to get 640 by 480 from the camera. So give me a second here. Oops, I need print array. One more time. Okay, now I'm looking for FaceTime HD camera, 640 by 360, really? That's fine, 30 frames per second is cameras 3. And I'm gonna say 640 by 360. Let's start this off. So what I'm doing, by the way, if you're confused, is I'm just trying to get my previous example. I made a video a long time ago about kind of computer vision in general, and I had one example which does tracking of a red color. So I thought, yeah. So this is where I'm sort of starting with. And so what I'm going to start with, the first thing that I'm going to do is you can see that there are some things about this that kind of work in that I'm able to effectively track this cup's location, but you'll notice this sort of like circle is jumping around. So this particular example is looking for the single most red pixel. And what I want to do in talking about computer vision is a few things. Number one, I want to look at how I would then find the average location of all red pixels, which will give me something more stable and more accurate. From there, I also want to look at how I would then track motion. So I think looking at tracking motion can be useful, pixels that are changing. And then from there, I want to look at actually blob tracking. So not just the average location, but thinking about what is the sort of what are the dimensions of this blob of red pixels, and then what happens when I have two of them, and can I have multiple blobs moving around? And you know what? If I just use the red color, I don't need a tabletop. This will work. So and yeah. So and then I can also I have my permanently. Ta-da! Okay, so I think we're ready to get started with some of this computer vision stuff. I apologize for taking so long to get going with this. So let me get back to this particular example. I'm very frustrated about the red error messages with the cam twist thing. There must be like I want to like there must be a driver somewhere that cam twist. What if I do? There's still something on the computer. Ooh, what's this? Ah, look at this. Ah, look at this. Let's do this. Ah, okay, hold on. I stupidly used that. Okay, hold on. We're going to make some magic happen here. Just bear with me for one more second. This is what I want. I want to do this. I think the drivers or whatever for cam twist is a great thing. I love cam twist. I was going to use it to show you something really kind of cool, but it's messing with my mojo right now. So let's see. This is already. I think this is what got removed already. Okay. So let's see if that helps matters. Oh, I should have just looked for that earlier. I'm such an idiot that I didn't do that earlier. Okay, yay! So great. And so here I am, 640 by 360 is still cameras 3. Great. Okay, so things will work a little more smoothly now with no error messages. Yay. Okay, now I need to go to the browser, and I have to find these two things that I want to reference. Open frameworks, computer vision book. So somebody correct me if I'm wrong, but this is by the way, this website that I'm at, which is openframeworks.cc/ofbook, is a online book about using open frameworks, which is a C++ creative coding platform. And I believe that a lot of this material was put together at a doc sprint that happened at University of Denver, the EDP, what's this program? EDP Denver. Emerging Digital Practices at the University of Denver. Great program. Chris Coleman is there. He supports a lot of wonderful creative coding types of things. Anyway, I am not going to work with open frameworks in C++ in this particular video or session. However, you will find that a lot of computer... Is there still a cup taped next to me? Yes, I love that I'm doing this whole tutorial with a cup taped next to me, which is now also like this weird cup that looks like it's on my computer screen. Okay, I don't know what I'm doing here. This is all making me very uncomfortable all of a sudden. Okay. I was talking about something meaningful and important. Now, yes. So you will find, if you do research about computer vision and look for examples of artists and scientists and all sorts of other people working with computer vision, that a lot of the open source libraries and examples and tutorials are written with sort of C++ as a platform. There's a number of reasons for this. Number one, one of the core things you have to do with computer vision is read pixels. And reading pixels can be a slow and expensive operation. And C and C++ being a kind of language that allows you to program kind of lower level native to the computer itself, you can kind of squeeze the most speed out of that. I'll say that processing actually runs incredibly fast for doing this kind of stuff too. And for many things, it's going to work just fine. And also just a lot of the libraries. So there's something called OpenCV, Open Computer Vision, which is probably one of the most well-known computer vision code libraries. It is written in C++. So if you happen to be, writing an application that you want to use C++, if you want to use OpenCV, writing in C++ could make a lot of sense. There is a processing library for OpenCV. There are lots of computer vision libraries for JavaScript. And so I'm going to stay in those worlds. But I encourage all of you watching or participating or learning to explore some of the open framework stuff, to communicate with me. Maybe we can port some of the examples back and forth. So, so that is one thing that I just wanted to briefly say about that. The reason why I'm also showing you this, I just noticed last night, is that let me go to. So this is a article written by Golan Levin. I'm going to try to make it something that you can see here. And what's great about this particular article, and I encourage you, I will include a link to this in this video's description, is you're going to get a nice historical context. It might sort of seem like, oh, computer vision, that's a new thing. Or OpenCV, there's this great OpenCV library, not new being in the last 10 years kind of thing. But artists have been working with computer vision ideas, since the late 60s and possibly earlier. But you can see Myron Kruger being kind of a seminal example of that. There are other examples of Golan's own work. And other types of things that you would look here. So I would encourage you to read through this. The other thing that I think is particularly useful about this article is this section called Elementary Computer Vision Techniques. And this is kind of my goal here in this session, is to show you how to perform these elementary computer vision techniques from scratch, with the sort of raw guts of the code to understand how these algorithms work. In practice, you might find it more convenient to just use a library that's going to have it implemented already. But I think the idea here is that, number one, it's kind of interesting. You might just sort of enjoy this in an academic sense to sort of learn. The other thing is to use the library, it's often helpful to have a kind of an understanding of how the algorithms are working in order to be able to manipulate the parameters and stuff of the library. But also, to be honest, you might come up with some creative, weird, strange idea, application, technique that isn't possible, that isn't baked into a library. So I think it's worth kind of looking at these stuff. So I'm going to read these to you. Detecting motion. This is something I definitely want to try to do today. Detecting presence. We could look at this too. Detection through brightness thresholding. This would be useful. Simple object tracking. Basic interactions. And then there's some more stuff here about different examples and authoring tools and that type of thing. There are also source code examples: frame differencing, background subtraction, brightness thresholding, brightness tracking. You know what might be useful to do? This says the following programs are known to work with processing version 135. Let's do something for the world today, and let's download each one of these examples. And let's check them and make sure they're working with the latest processing and update them if they're not. I wonder if these are GitHub links or no, these are just straight files. So I'm going to do that first in this session to kind of as an overview thing. So I encourage you to check out this. I think would give you some nice background and context to the tutorials that I'm going to do. And I also just want to credit them because a lot of my knowledge or ideas come from these tutorials. And I think this Open Frameworks book also is great. I mean, and there's a lot of really important key stuff. One like really fundamental diagram. I have video tutorials that go over this already. So this is knowledge that I'm going to assume in the tutorials that I do today. But this is sort of a key thing that you need to be comfortable with in terms of how the pixels look, how the pixels are numbered, and how they're stored in memory. And then the other aspect of this is, maybe there's not a diagram here. I have to find my own diagram for that. But which is how to think of the pixels as x, y pixels, but look up that individual index in that one-dimensional array. Okay, so that is some background. So the first thing I'm going to do just to kind of get warmed up, I think, is I want to open up these examples. And you know what? Maybe we're going to make this. I want to open up these examples and see that they work in processing 3. But if you have questions or comments or thoughts, there's still a cup here. It's a little bit weird. Please let me know. Yes. So one question that's asked is, could you try to do an authentication through retina scan or face detection? I absolutely want to do, in a way, like, so first of all, in case you're not aware, where I am keeping track of my list of topics is in this GitHub repository, coding rainbow/rainbow topics. So you can open a GitHub issue to suggest a topic. You can also upvote them, because one thing I can do here, sorry about this, let me just make this a little smaller, I have the possibility to go sort by reactions, and so I can sort by thumbs up. And you can see that computer vision is right here on the top, and I have an outline of the things that I'm planning to do, and you'll see that, I don't know why I'm backwards here, you'll see that I have on my list face detection. A long time ago I taught a course called Face It, which was just a whole course only about things you can do computationally with faces, face detection, face recognition, tracking, eye tracking, that type of stuff. So at some point I'd love to expand that playlist. I have this list of stuff that I want to do in this YouTube channel that is, if I was doing this, even if I was doing this every day for it would probably take me a year to get through all this stuff. So we'll see. But this is kind of what I'm working with. Okay. So let's get warmed up here, and I'm just gonna, let's go to frame differencing. So I'm going to open up processing. I'm gonna save this as, okay, I wanna make a folder on the desktop here called, I'll put it under coding rainbow and computer vision. And then what I'm going to do is save this as in the desktop of coding rainbow, computer vision. Let's get a shortcut to that here. And let's save this one as frame differencing. So, oops, that works. Oops, I lost that code, yeah. So this is frame differencing by Golan Levin. Oops, I'm sorry, I'm frame differencing. Paste this in here. Let's run this. So I'm assuming that this isn't going to work. And you can see that it is not working. So let's update it for processing 3, and let me see if I can find some of the things that are different. So the video library, so the older version of the processing video library used to be built on top of QuickTime, and it's currently now built on top of something called GStreamer. And one of the things that it needs is video.start, and that might be actually all we need. You can see, and we had it there. Oh, there we go. So this is now working. So it turns out that all I actually needed to do for this particular example was add that video.start. I would like to change one other thing, however. I think this is a very reasonable way of doing things, but I rather prefer to use the capture event, and I will, rather than if video.available. And I'm a little skeptical of this load pixels in setup, but it's interesting that that works. I'm sort of surprised. This, I think, should be in draw, but let's see what happens here. We might get some weird flickering based on what I did. Yeah, notice that. Do you see that flickering? So let's see if we can eliminate that flickering. Oh, look at that. Interesting. Oh, I like the way that this is being done. So, okay, I'm not going to get lost in this example because I want to make some other changes to it. But okay, but let me just cover at least what's going on. What's happening here, and I kind of screwed it up, and I'm gonna get to that later. But what's going on here is you can see if I'm completely still, the window is black. And as I move, you start to see these colors. What's happening is a video image is a frame of pixels followed by a frame of pixels followed by a frame of pixels followed by a frame of pixels. And what this example is doing is it's taking a current frame of pixels and comparing it to the previous one, and taking each color, each red, green, and blue component, and subtracting the previous. So as the pixels move, we're seeing the difference between those two colors. So I have a feeling that each one of these, and actually I'm going to come back to this later. Each one of these is probably works just fine if I just add the video.start. So someone remind me, I will get in touch and see if I can help. So this is actually really useful. I want to use this. Look, there's the cup. So I want to use this idea of thresholding as well during this discussion. OK, we better just get started. I think I want to start doing the actual programming of stuff because I've been going for almost an hour just kind of getting myself set up. OK. So I want to reference Golan's article. I want to close this. I want to get my processing code up. I want to start with this particular example, which is going to track this particular cup. So that's working well. And then the other thing that I'm going to need is the whiteboard. Let's see if that exists. How's the focus? If someone in the chat could tell me if the focus on this is reasonable, that you can read what's here. I don't know why today feels like all of a sudden feels like a very serious, oh, and I'll turn this light on. I like to have, oops, this is not plugged in. Never mind. Turn this light on so let's give it a little more light here. Maybe that's not necessary. Can you see this whiteboard okay? I'm going to get out my new markers. Okay, I'm hopeful. How's that? Can you see that? Can you read that? Let me plug this. Just going to fix one thing over here to get this light plugged in. In the corner. Tends to work well. Whoops. Oh, what a disaster. I got to use the tape here so I don't trip on it. Okay. Okay, this is sort of silly what I'm doing, but I'm doing it anyway. Okay. Okay, I think we are about ready now. Let's see. Focus is good. Eyes are a little small. Okay. So the other thing, I think that's fine. I'm going to zoom in here. OK. So, oops. Let me tape this a little bit further over so I can stand here and be talking about this tracking thing. And I think, and if I stand here, like, I can't, this stand here. OK. Great. OK. So I think I am about ready to go with this first tutorial. By the way, Alvaro asks, is there a way to find the red pixels without searching all the pixels? Not really. I mean, here's the thing. You could search, you could come up with clever things. Like, for example, let's say we know where the red pixel is. It's like, this is so weird. Like, I'm pointing here, but I can point here. I'm lost. OK, let's say you know where the red pixel is one frame. Well, you could start by searching the pixels near there to see if you find the red pixel again. And that way you could say, I found it, let me not look anymore. But ultimately, you need some sort of higher level logic to strategize for how you might. You could do something like, I'm just going to look at every 100 pixels. And if I find something reddish, then I'll start looking in more detail around that one. So you could skip a lot of pixels, that type of thing. OK. So I'm going to put this camera aside. I'm going to cycle this. apologize today for how long this took me to get up and running with this stuff. So in this first video, what I'm going to do is move from looking at a single pixel for the average location of a bunch of pixels. And I'm going to also kind of introduce the idea of computer vision a little bit. Do you guys hear a hum of the fans I have going in here? Hopefully not. It's not so bad. OK. So let me get my code set up a little bit here. And then here, okay, let me close things I don't need. Okay. I think it would be nice. Let me find a nice image. Here we go. Okay. Very low hum in the background. All right, let me see. Better? How's that with the hum? Better? Okay, I'm glad some of people have just tuned in. For those of you who just tuned in, I not wasted, but I spent 45 minutes just trying to get to this point. But here I am. I'm at this point. Oh, you know what I also have are these. These are little like colored Post-it notes, and I could put those up in addition to this cup thing. But let's just start with the cup thing. Okay, here we go. I'm going to start the first tutorial, which is going to be, again, just reminding myself, reintroduce the idea of computer vision, reference the Golan-Levin article, talk about the sort of classic techniques, and then moving to libraries, and then show my example and transition. Okay, here we go. Somebody asked what's the URL of that page. I think Oliver might be the only person who can paste a URL into the chat. But it's if you just search Golan-Levin computer vision, it will come up on Google. OK. Hello, welcome to a continuing series about computer vision. Now, OK, hold on. This is weird because I feel like I'm starting fresh, but I am actually continuing a previous video that I made over a year ago in terms of where it's going to be in the playlist on YouTube, but let's just see how this goes. Okay. Hello, well, okay, thank you, Oliver. Okay. Hello, welcome. I'm here in this video to talk some more about computer vision. Computer vision being this idea of having a computer see, having a computer find something. If you notice, there's this strange red cup. This actually isn't part of my computer screen. This is a red cup here taped to the wall behind me. And in a second, I'm going to have a camera pointed at that. And I want the computer to be able to find that red cup. And this is going to open up a lot of questions around all sorts of different techniques and strategies of getting things that are faster and more accurate and that sort of thing. So the first thing that I want to do, though, is reference for you a source of inspiration for me, which is an article by Golan-Levin called Computer Vision for Artists and Designers, Pedagogic Tools and Techniques for Novice Programmers. So there's a link to this article in the description. It gives you some historical context, and it also walks you through some sort of key classic techniques like detecting motion, detecting presence, detection through brightness thresholding, simple object tracking, etc. And I'm going to demonstrate a lot of the techniques which I've learned and taken inspiration from this particular essay, online essay. So, okay. So the other thing I'll mention briefly is what my strategy here for this set of tutorials, there's going to be a whole bunch of them. By the time I'm done, there could be up to 10 even, is that I'm going to show you how to program some of these classic algorithms from scratch. And then from there, I'm going to transition to showing you how to use different computer vision libraries that have these algorithms and more sophisticated versions of these algorithms baked into them. So it's a question of, in practice, a lot of the time you probably want to just use a library like OpenCV is one of the ones I'm going to show you. But there's some value in understanding the algorithm for when you go to use the library, for knowing how it works. Plus, you might invent some sort of wacky, creative, new ideas around computer vision and just sort of creative visualization by playing around with these, by writing the algorithms yourself. Okay, so a previous video, I started with an example that does exactly this. So, and this is an example running in processing, a Java-based platform. I will make P5.js JavaScript versions of these examples, which you can find hopefully linked in this video's description as well. But here you have a cup, a cup taped to a green wall behind me. And what you can see here is that I'm drawing a circle at that cup's location. Now, how did I do that? The way that this particular algorithm works is it says, look at every single pixel. Is that pixel red? Is that pixel really red? Is that pixel more red than the other one I found that was kind of red? It's looking for the most red pixel. For every pixel, find its color distance, its difference from red, and find the one that holds the record for being the most red, and then draw a circle at that location. But there's an issue. While this is working somewhat accurately, and I could even take this off the wall, you can see it's kind of following it around, but it is sort of jiggling. I could also demonstrate another problem by having two cups now, and like now it's jumping back and forth between the two. So there's a lot of things that I want to resolve here in the way that I'm going to improve these examples. The first thing that I want to do is simply make it so that I can get a stable location, hopefully in the center of this particular cup. And so the first thing I can do with this particular example, and also, by the way, notice now it's not finding it anymore. This camera is doing some like auto white balancing brightness stuff, which is really can be a problem, and I think there's some ways of turning that off. But in the sort of real world, if you take this to an installation or a project you're making, you're going to want to have a camera that you can turn off auto white balance, auto all those sort of other automatic settings. But I can, in this example, I can always click and kind of recalibrate the color that I'm tracking. So the first thing that I want to do is, instead of looking for, in this particular video, instead of looking for the single most pixel that is the most red, I want to say, is a pixel red enough? Find all of those pixels and give me the average location of all of those pixels. So let's dive into the code and make that change. Okay. As you'll notice here, every single, the core algorithm of essentially all computer vision, let me look over here for a second. The core algorithm of all of these computer vision examples is this nested loop. For every X pixel, for every Y pixel. And something is really bothering me here. I don't know why these extra spaces are here. And I'm going to sort of do autoform. I need to put some spaces here because I have a problem. Please don't be like me. Live your life with spaces in weird places. Okay, but and you can see here, what am I doing? I am taking, and let's just review this for a second. I have a new whiteboard marker that I've, oh, there it is. Let's just review this idea really briefly in case you didn't watch the previous video. This is a grid of pixels. It has columns, which I could number like this, 0, 1, 2, 3, 4. It has rows, which I could number like this, and let's just make those different for the sake of argument. Then it has pixels. The pixels are numbered like this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, etc. Every single computer vision algorithm that I demonstrate to you will start with for every X, for every Y. So it's looking at every X pixel and every Y pixel, but then it needs to look up a given pixel here in the one-dimensional array of all of the pixel colors. And the formula for doing that is X plus Y times width. And you can see why that would work, because here the width is 6. The first pixel in column 3, and X3 is 3. The next one is 3 plus 6, which is 9. The next one is 9 plus 6, which is 15. Is that right? 11, 12, 13, 14, 15. So this formula is going to be kind of key. So that's right here, right? For every X, for every I, find that pixel location, and then and then I need to separate out the red, green, and blue components of the color that's coming from the pixels of that video. And then there's this other color called track color. That's the color that I'm looking for, the red, is that here? Yes, the red cup. And then using the distance formula, and to be honest, I should really not use the distance formula because it has a square root. I should use just distance squared, because then I don't have to take the square root. But I'm not going to worry about that optimization right now. Maybe I'll bring that in later. I'm checking to see if it's if it beats that sort of record, it's the most red, and I have that XY spot. So that's what this code is doing. So now in the next version of this example, instead of looking for instead of looking for the most red, I want to look for anything that is like red enough. So the first one thing we need is a threshold variable. So I'm going to add to this program, I'm going to add a variable called threshold. And I'm going to try this just at like 25. I sort of made that up, 25. I want any given pixel that is within, that's difference is less than 25 from the color that I'm looking for to be considered red. So let's go down to the algorithm. And I'm no longer looking for a record or a closest x or a closest y. What I'm really looking for is like the average x and the average y. And I'm going to make those floats because, yeah, I think that's going to help out in a little bit just in terms of doing the average stuff. And then I also need to have a count. How many pixels are red? Okay, so I need to ultimately what I want to do at the end is have calculated the average. And then I also I need to keep track of how many pixels, because that's how I'm going to calculate the average, by the way. OK, so now we're looking through. We find the current color. We know the track color. We know that difference. So I'm no longer checking, and I'm going to save this, by the way, as computer vision 2. I'm no longer checking, is that distance less than the record? I just want to know, is it less than that given threshold? If it is red, somewhat red enough, then what do? Average x, I add its x location in. Right? I add the y location in, and then I increase the count. Now, those values aren't really average yet. How do you take the average of 5 numbers? You add all 5 up, and you divide by 5. So this is what ultimately I'm going to do here. The code's over here. I'm going to add up all of the x's and y's, keep track of how many x's and y's I added up, and then take the average. So now at the end, I can say as long as count, let's just say as long as we found at least 1 pixel, I could say like, you know what, this only works if I find 5 pixels. That might be more accurate. But I'm going to say as long as count is greater than 0, I'm going to say average x equals average x divided by count. Average y equals average y divided by count. I'm going to fill with the track color, give it a stroke, and then draw the circle at average x, average y. So you can see now here, instead of looking for the single most pixel, any pixel within that particular threshold of red is going to be considered red. So let's run this now and see what we get. Now, I don't know if I picked a very good value with value 25, and I should really make that a variable that I can tweak in real time. But let's just sort of see. OK. Now, what I'm going to do is click here to set that color. You can see that's pretty good. It actually is still sort of like moving around. One thing that I think could be useful to do is I could actually show you which pixels I found. And what I'm going to do that, I think, is just do, this is like not so great, but I'm going to draw just like a point there to sort of see a white point to see what it's sort of finding. And the other thing I want to do is I'm going to, just right now, I'm going to map the threshold between mouse x, like the lowest threshold would be 0. Oh, the mouse x goes between 0 and width, and I could have a threshold between 0 and, like, let's just say 100. So this might make things run kind of slow because I'm going to be using the point function a lot, but let's sort of see what happens here. OK. So let me click here. You can see, oh, why are those all? So first of all, didn't I say fill? Oh, point, by the way, is a stroke. And I want to say stroke weight 1. And actually, just for a second here, let's take, let's do this. And let's make this a little bit smaller so we can really see what's going on here. OK, so let's run this. And we should see a white pixel for every pixel it's finding that is red-like. And you can see what it's found here. Now, oh, look at this. So the threshold is very high. So you can see even my hand is kind of within the threshold now. So, and you can see as I move the mouse, that threshold, my skin is kind of like reddish. But as I move over here, you can kind of see what's going on. Now, I want it, wow, my lips, I got to get out of the frame. So you can see now it's quite stable. There you go. So I found kind of an appropriate threshold. I should have a way of like printing that value out so I know. And you can see that it's, whoops, as soon as I move in the picture, we're gonna deal with that in a second. I want to zoom in here. I should be able to, unfortunately my arm is too red, but I should be able to take this off and move this around. And you can see that I have quite a pretty accurate tracking as I move this, and it's quite stable. So you can see that even just doing the average location, you know, again, I have nice lighting in here, I have a green background, I have a very distinct color that I'm searching for. But if this were an interactive tabletop where you could control the lighting, you could have red discs on top of a green table or white discs on top of a black table, then this is something you could do. So I've shown you one improvement here. The first improvement is just using the average. And again, as soon as I introduce another cup, you know, we've got a problem. Look at it. That dot is right in between them, right? Because it's the average location, which is kind of interesting, but not what I'm looking for. So in the next video, I'm going to look at tracking motion, which I think will be interesting to see. But the video following that, I'm going to show you how you can track each of these locations as blobs separately. OK, so that concludes this particular video. And in the next video, we're going to look at motion tracking and frame differencing. OK, how was that? Was that useful for everybody? Did that work? I have no idea how long that was. So that was hopefully good. There was something that popped into my mind right at the end there that I wanted to do. But I can't remember. Oh, I wanted to get the threshold value. I want to know that threshold value so I can use it. Let me just do that right now. Let me click here, kind of like see that seems pretty good. I'm not, how do I, anybody have an estimation? Okay, hold on. What I meant to do was print line mouse X, or print line threshold. Let's do print line mouse X, comma threshold. This is what I meant to do. And now, come back, camera, click. I think that's, so I'm at a threshold of like 80. Oh, and I forgot, I was going to add the distance squared thing. So a threshold of like 80 is pretty good. Keep that. Gee, I wonder. OK, so I guess my question for you guys is, I think I'm going to go and do the frame differencing thing to look for motion pixels, because I think that's kind of interesting to see for how that works. Yes, so I was just using point just to be quick and dirty about it. I wouldn't usually do that. I would use either set, or I would actually use the pixel array to draw that. But it's kind of, it runs fast enough right now, so it's kind of good enough. So what I want to do, I'm going to do the frame differencing. So save this. Let me rename these actually for a second. So let me rename these computer vision. Whoa, oh no. Oh, I didn't save this in the right place. So this one was average color tracking, average point color tracking, call it that. And computer vision 1, which was where? Which was maybe just on the desktop? Oh yeah. This one is, whoops. What did I just do? Something crazy happened. Oh, I hit present mode by accident. Yes, I am planning to use OpenCV at some point. It was asked in the chat. Let me just save this example as, oh yeah. Computer vision, this one is a single pixel color tracking. Okay, single pixel color tracking, and then Average point color tracking. Okay. Okay, so the next thing that I want to do, and let me cycle these cameras. Is I want to look at detecting motion. And so to detect motion, this would be good to do some dancing in this video, perhaps. Maybe I better have my music ready. Okay. Yes. I think I'm ready. I played the music twice. Okay, sorry. Okay, in this particular video, yes, show us to make a circle detector so we can find cups of any color. Yeah. Well, all this is possible. Okay, one step at a time. Now, my nose is still running. I had this terrible cold a week and a half ago. And I'm going to mute my microphone so I don't. Okay. So the next thing I'm going to do is motion detection looking. Oh, yeah, no. I can't remember. Is there a distance squared function in processing? No. So I know there's a mag squared for the vector object. Distance squared processing.org. I don't think there is. So I could keep it this way. What I would do is just write my own function, and maybe I'm going to do that. So I'll do that at the beginning of the next video. I'm going to write a distance squared function, in which case it can eliminate the square root, which I think will be useful. Okay, so let me get rid of this stuff at the top. I want to have comments in my code, but I find them a little less useful while I'm doing these tutorials. Okay. Okay, here we go. Whoops. Okay, now I am ready. So in this video, I'm going to talk about detecting motion. We were searching for a color, a specific color. Now I'm going to search for a specific sorry, I'm losing my mind here. I'm going to just look for pixels that change. And then I am going to, I'm going to optimize the distance squared thing by adding my own function and then look for pixels that change. Okay. Get this up and running. What happened to the cup? Oh, right, this has to be like this. Okay, here we go. All right. Oops. Here we go. Hold on. I think that I don't need, I just want to, I think it actually will be fine to have this bigger, and let me just see what this looks like for. Okay, great. Okay. Hello, welcome to another computer vision tutorial video. Now, in the first video, I showed you how to find the average location of all of the red pixels in this particular image. And you can see over there, I'm pointing over here. Okay, no, start over. I'm so used to looking at a preview of myself. Okay, start over. Hello, welcome to another computer vision tutorial video. In the previous video, I looked at how to find an object of a certain color and find the average location of all the pixels of that color, which allows me to very easily track an object like this. And you can see I can kind of move this around and I'm tracking it. Now, what I want to do in this next video is look at something related but a little bit different, to look at how do I find pixels that have changed. So in this sense, I'm writing a motion detector. Motion is pixels that are changing, right? Because if everything is very still, none of the pixels are changing. But if I move, those green pixels are suddenly becoming my skin color. And so my skin color pixels are suddenly becoming green pixels, that sort of thing. So I'm going to start with this code example. But before I do that, let's add just a little sort of simple optimization to it. We don't really have a speed issue. This is running very, very quickly. But this can, as you move to higher resolution, become an issue. I did mention in the previous video that this particular algorithm, right, I'm finding the distance. Seems weird. Distance between two colors. Well, you can think of this three-dimensional space that we live in as a color space. And each color, the x-axis of this space being red and the y-axis being green and the z-axis being blue. And so colors that are near each other in the space are more similar. So that's how this sort of idea of Euclidean distance works. But the truth is the distance function uses a square root. So I'm going to write my own function here, down here. I'm just going to call it distance squared, and I'm going to give it 6 arguments. Whoops, this should be x2. And what I want is to get that distance, which is x2 minus x1 times x2 minus x1 plus, and then I want to do the same thing with y. So it's the difference between x, the x values, the difference between the y values, and the difference between the z values. All of those values squared and added together. Now the actual distance formula would then take a square root of all of that, but I'm going to not do the square root. Thus this function is called distance squared. I'm calling it distance squared. And so I can just change this to this. And then what am I checking? I'm not checking against the threshold anymore, but I'm checking against the threshold squared. And now I don't have any square root function, which will make the code run a little bit faster. And this could also, I could eliminate having to square it by just like using the value that's already squared, but I'm making the point here. So you can see this works exactly the same way, same exact math, but I've eliminated a square root. Okay, now that I've done that, let's start moving on to thinking about how I can do this frame differencing. Okay, so the first thing I need to deal with is the fact that I have this capture event, right? In a separate thread, the video library is calling this event function, capture event, every time there's a new image available from the camera. Video.read, here's a new image. Video.read, here's a new image. Video.read, here's a new image. So what I need to do is right before I get that new image, let me copy the previous image to save it. So I have the previous one and the current one. So what I want to do is add actually a p-image object. I'm going to call it prev for previous. And then what I'm going to do here is say previous equals create image, and I want it to be exactly the same dimensions as the video, and I want it to be an RGB image. So this is making a blank image in processing. And then right before I'm about to read that image, I want to say previous dot copy the video, and then the copy function in processing says take the pixels in the video and copy them to this particular image. But you can do all sorts of crazy stuff. Like you can take a little bit of this image and copy it here and stretch it out. But I'm not going to do anything that interesting. I'm literally just going to say copy the whole video onto the whole previous image. So I'm giving it 2 rectangles. And the other thing that's probably worth doing is saying update pixels. So this now I should have previous and the current video. So if we run this, let's just run this to make sure there are no errors. My shoe is untied. Ooh, look, I have a knee. I don't think I've ever shown my knee in any of these videos before. And that'll get edited out. Okay, so you can see this is still working, nothing's changed, but behind the scenes, there's this previous image. So what I want to do now actually is change what I'm doing. Oh, and I think I might have messed up by not saving as. Let me do this right now. Motion detection. So what I want to do right now is actually look at every pixel in the current image and compare it to the previous one. Okay, so I'm going to lose this idea of a track color because I'm no longer tracking a color. And instead, what I want to do here is I want to get not only the current color, but I want the previous color, which is from the previous image. And I'm going to call that R2, G2, B2. And then I can check the distance between those. I can check if they're less than some threshold. Now this is a difference threshold. How different do they have to be considered motion? And I'm going to leave all this average stuff in here because I'm going to use that in a moment. But just so you see it right now, what I'm going to actually do is say load pixels. And in here, I'm going to actually just draw to the pixels array of the display itself. And I can use that same location. And if it's a motion pixel, I'm going to set its color to white. Otherwise, set its color to black. And then at the very end, I'm going to say update pixels. So, oops, we don't have track color anymore. So now I'm going to run this and take a look at what happens. Come on, video, come alive. Oops, OK, we got an error. Previous color equals previous pixels location. Now, where did I miss? I never said previous load pixels. So because I'm going to look at the pixels of that previous image, just like I'm looking at the pixels of the video, I've got to actually call load pixels. OK, let's run this again. There's a lot of waiting here. Come on, video! I still have an error. What did I miss there? Array out of bounds exception. I don't see why I should have an array out of bounds exception. I make the image exactly the same as the video size. I copy it. All right, we're going to do some debugging here. I maybe edit the debugging out. I'm not sure yet. Let's look at these particular values. Ooh. Oh, you know what's going on? It takes a while for the video to be ready. That's weird. It really shouldn't matter, though, because the previous video, why is that not? Oh, you know what? This is, interestingly enough, the video's width and height does not exist yet here. I just realized that. So because in setup, it hasn't really happened until here. So right now I'm just to confirm that that's the case, I'm going to hard code these values in. And that should fix it. But and then we might think about a different way of doing it. Yeah. So that's going to fix the problem. Except I don't see anything happening. OK, let's see here. OK, hold on. Let's make an edit point at some point earlier. And I'm going to, because let me just figure out a couple things that maybe I missed. Because I have a feeling that my order of operations is off. Because let me just do this for a second. And let me also do this. Come alive. There we go. So I can't tell. White is, does it think every pixel is really different? Oh, this should be greater then. right? If it's greater than that, make it white, otherwise black. But it thinks that every pixel is not different. So I think I knew this would be a problem. The problem is that I'm reading the image and copying the previous one, but I'm doing that separately from what's happening in draw. I know I could fix this with just saying, let me confirm that this is the issue. To not use capture event, just for a second. So I should say video.read, and then at the end, I need another. Let me get it working, and then I will continue that video tutorial knowing how it's going to work. Oh, no read down here. Sorry. Now, it's still, OK, good. That's interesting. So maybe I need. Hold on. Let's just do something. So what's going wrong here? How are we doing time-wise? OK. So there's definitely something. Can you see if there's a delay? One frame delay, I can't tell. Hold on. Let me check one other thing. Only if the mouse is pressed, let me do this copy. So this isn't even working. OK, so something else is wrong. Let's see. That's good. Oh, how is this still in here? Take this out. If distance is greater than threshold times threshold. OK, hold on. If distance is greater than 1, make the pixel white. I must have messed up this function. Let me use the regular one for a second. Try that. Debugging. I need my debugging music. Yeah. OK. So why are we not getting? Forget about this for a second. Do I have something wrong with my pixel stuff? Oh, I never said load pixels for. Oh, yes, I did here. Terrible error. Do you guys see it now? There it is. I copy pasted it, but I didn't put the previous color in there. OK, that's good. R2G2B2 is my name. Yay, OK. Ooh, very slow, very, very slow. Why? Because I'm using the, OK, let's fix a bunch of things. Let's go back, get rid of this. Put this back in. OK, I'm going to walk back to what I had previously. Everything's different. Save. OK, now this is working. It's just, so by the way, this is just showing the pixels that are different from where it started. And I can freeze frame it. This is actually quite useful to show, which maybe I will. But let me get back to what I had before. Let's see if I can. There's a certain way that I prefer to write these examples. And I just want to see if this will work this way. And I might have the issue that I think I'm going to have. But this is what I had previously when I started debugging. Okay. I didn't have this. Let's see here. Look at that. So, oh wow, interesting. And why? There was like a lot of noise for a moment at the beginning, but now it's doing what I expected it to do. Okay, what was all that? Ooh, look at this, people doing strange things with software. Different thing. Okay, but I could also change the threshold. So, oh, because of the threshold. So let me give it a kind of reasonable threshold of like, okay. Okay, so back. Sorry, everybody. Thank you for your patience. Let me just start off with the threshold of 50. Video load pixels. I can't. I think I didn't have video load pixel, previous load pixels. Okay, so the thing that I need to show, this is what I had wrong. So I'm going to put that back. And I had this by accident, which is fine. And I don't need these there, although it's nice to sort of have those for reference. Okay. Oh, and then this was the issue. Okay. Okay, I'm going to come back. Yeah, the noise is due to the auto white balancing but also just that threshold was so high. Okay, I'm going to come back into that tutorial. This will have to get edited together. And fix those two bugs and keep going. Oh, hey, hello, Cup. Okay, here we go. Back after a moment of debugging. Maybe I need to give a little space there in case it's harder to edit. Let me do this again. Back after a moment of debugging, there are two key issues that I had in my code that caused a lot of problems. Number one is something that's a little bit of a nuance to the way the processing video library works, but the video stuff is happening separately behind the scenes. And by the time we get down to this line of code, the video actually, the camera hasn't like opened its connection yet, so the video width and height doesn't actually exist. So I could be smarter about how I create that image, but I think just to get this example working right now, I'm just gonna hard code in the width and the height. I know that my camera is giving me a 640 by 360 image, so I want my background image to be that as well. The other thing that I didn't notice I had as I went over here is, right, the current color is from the video, the previous color is from the previous image, the previous frame. But I want those red, green, and blue second values to be not from current color, but from previous color. So I've got to fix that. And now that I have that, the other thing that I think might be necessary, or maybe it doesn't matter. Oh, I might have not had this in there. So I need to also make sure that I'm loading the video's pixels and the previous pixels. And so now we should be able to see white pixels wherever there is no motion, meaning the pixel is the distance is less, and black pixels where there is motion. So let's take a look at that. And let me try to zoom in here so you can see what's going on. Come on, image. So you can see it's very, very white. And now you can see if my arm is very, very still, there is no motion. But if I move my arm, the pixels are black. So you can see around the edges, and I can kind of walk in. And you can even see, like, if I move the t-shirt around, you can see this. And this would be a good time to see what happens with some dancing. Motion dance detection. Okay, I bet you weren't expecting that. And now you might be sorry you're watching this video. Okay, so there's a couple more things I want to do with this. Number one, let me just show you something interesting about this. I sort of actually also weirdly feel like reversing that. So let's see the white as the black as the background and white pixels otherwise. But one thing I want to show you is I'm actually, every time there's a new image from the video, I'm copying the previous one. But I could also, by the way, say, hey, let's take this code and just add it in mouse pressed. So what this is doing, you'll see in a second, is as this runs, speed up here, you're going to see it's all white. I could click, and now it's all black. I'm going to click again. There's a lot of auto white balancing going on. You can see here that now it's just showing me pixels that are different from the background because it's memorized the background. You know, another way that I could make this a little bit more clear is at the end here, I could draw the video and draw the previous one. I'll make them kind of small at the top. This is going to make things a little bit more clear. Are you running? Run. Come on, computer vision time. So you can see here now, this is what it's comparing. It's comparing, you know, this image up here to the one on the right. And if I go like this, and then I move, you can see that's now. Unfortunately, the camera auto white balanced. So if I had a camera that didn't auto white balance, you can see I could come back into my spot and try to find it. Oh, look, I can't get there. Oh, there I am. No, OK. Anyway, you get the idea. So I could be out of the frame and save it. Now it's the background. Now that cup is shaking. It stopped shaking. Save it again. And I could move my arm in, and you can see I'm getting a really nice silhouette. So this is the kind of thing you can do also for getting silhouettes. But you want good lighting. It really helps to have a solid colored background. You don't need a green screen, but certainly that's helping the cause here. But really, you need a camera that's not going to do all this auto white balancing stuff. You can see how quickly it changes. OK, let's add one more thing to this now, which is that, remember how we were looking for the average location of all of the red pixels? Well, I can now do exactly that here. I can say, anytime you find a motion pixel, a pixel with a distance greater than some threshold, then also what I want is to see that particular pixel. And I'm going to fill it white with a black. OK, so let's make it some like pinkish color so we can really see it. And maybe make it a little bit bigger. So this is going to be interesting because what I'm going to do is look for the average area of motion. And let's see what that gets us. Oh, I didn't mean to have, oh, whoops. Let me do a couple things here. Let's take these out. We don't need to look at those right now. And let's put this back in capture event. So we're always getting that previous frame. Awkwardly standing while waiting for camera to start. OK, but you can see I'm going to move out of the frame, and I can put my hand in here. You can see this is actually doing a pretty decent job of hand tracking because it's not perfect by any means, but you get a sense because my hand is the thing that's moving. Now, if I stop moving, it's going to completely go away. But I could store that. One thing improvement I could make to this is I could keep that location as a global variable. And if there isn't any motion, I could stay where it was last. Let's add that. So let's make this average thing a global variable. And over here, what I'm going to do is only alter it if there are at least, let's say, 20 pixels that are 20 motion pixels. Otherwise, it'll stay where it was before, and let's always draw it. So this is just a slight improvement to this that I think will help make it feel like it's doing something more along the lines of what you might expect or want it to do. So you can see I can move myself around. And now 20, I guess, is not that much. I guess there's so many pixels there. Let's just say there are 200. I don't know what's a reasonable number. There's probably, there's millions of pixels. So these are probably like such incredibly low numbers that I'm using. And you can see as I move, anyway, you can play with these values and get something that's doing something slightly better. But you can see the other thing that I would do here, and since we're here, is I'm just going to add a lerp x, a variable called lerp. I'm going to show you that you can use linear interpolation. I have a whole video all about lerp that I should link to from here. But I can say also the thing I can do is I can say, let me actually take a lerped point and always say, lerp x equals lerp between average x and lerp x, and actually I like to say lerp x first, I think, and then 0.1. So what I'm doing is I'm always just going 10% of the way towards the new point, which is actually going to smooth things out quite a bit. And I encourage you to look up my video about the lerp function, which would kind of explain how that algorithm works a bit more. And here we go, and that camera just went off. But I'm going to turn that back on, and so you can see the sort of final result that we have here. And the final result that we have here is that I have something that's kind of smooth as I move my hand around. Where does it go to? Why does it go somewhere else? I don't know. I have a bug in my program where it's like leaving and going somewhere else. I kind of want to fix that. Oh, because it's adding all this stuff up. Ooh. OK. Yeah. So this needs to be average x. It's adding up all those points, but only dividing it by count when it gets above 300. So I get that like added thing when it's less than 200. That was terrible. So what I want, actually, my global variable is to be the actual, I'll call this motion x, motion y. And I actually only want to update those, motion x and motion y. And then I want to lerp that. Oops. And this is now, I think, going to be a final version of this that works correctly. So I was always adding up all those values for the average, but then not calculating the average. And so that was making it go way off the screen. And you can see now I'm going to move off the screen. And you can see I have sort of a very rudimentary, like, as long as I'm moving my hand around and I don't come in the scene, I'm kind of getting, it's kind of following me in a sort of like nicely interpolated way. OK, so you can see that opens up a lot of possibilities. If I'm in here, it's going to kind of follow me around. I can turn my music back on, and I can do the pink dot dance. Oops. I am a magic pink dot manipulator. OK, that's hopefully you turned this off and you didn't have to experience that. So this is now a second video where we've looked at kind of how you can use motion frame differencing to sort of track a point around the screen. And in the next video, I'm going to return back to where we were tracking just this cup and looking for the average amount of red pixels to actually thinking about this cup as a blob, so that if I add a second blob, we can track both of them individually. OK, thanks for watching. Goodbye. OK. All right, how are we doing time-wise? It's 1:07. This has been an hour and 37 minutes. I want to do the blob detection. So I think in terms of my list, I'm going to do let me go back, because I screwed up. And let me get, let me open up I have frame difference, motion detection, single average point color tracking. I screwed this up and I started messing with it, right? Yeah. So I need to put this back to what it was. That's frustrating. But I don't think I went that far with it. Well, I added the distance squared thing, but that's fine. I want that anyway. OK, great. So I want to do blob tracking. So this is going to be, and I don't need the previous. I do want the track color. I do want the threshold. I don't need the previous. OK. Save this. So I think this is going to be, I'm just checking the chat. Will this lesson be, OK, so people ask, will this lesson be available offline? So for people who might be joining late, what is this? Who am I? Where are we in the world? Carmen Sandiego? No, I won't sing. You don't want me to sing. So this is a live session where I'm kind of stumbling my way through these tutorials. This entire live session will be archived on my YouTube channel. Then edited version, so far I've done 2 tutorials. So the edited versions of these tutorials will then become standalone videos, also on my YouTube channel. And then finally, that's it. Oh, and I do notice in the chat, it is true that I do have a Google Drive folder with all of the the raw videos that I give people who subscribe to the Patreon access to. Honestly, if somebody was at a school somewhere in the world and they wanted to use the videos, but they can't get a good connection to YouTube, I would be happy to share them. So if you have a compelling reason why you need the video files, I'm open to that. Okay. Oliver mentions I need to separate the average XY locally and globally. I guess I figured that out. Okay, so let me see here. I think I want to get back to this. Now, the blob thing is much more complicated. And what I'm going to need to do is actually there's a whole algorithm that I need to cover. And basically, the way I'm going to do this, I want to talk through this for a second, and then I'm going to do it again. What I'm going to do is, let's say this is the scene, and there are a bunch of blobs. I want to have a blob object. I think I'm actually ready to just record this. And what I'm doing is I'm looking for any pixels of a given color. When I find the pixel of a given color, I check to see if it's within a reasonable distance of some other pixel that I found. If it is, those things join together as a blob. If it is not, then it makes its own new blob. And at the end, I have a whole bunch of blobs. And I look through that list, and maybe I throw away blobs that are too small. Oh, this is going to be easy. I'm just going to do it. I'm ready for this. Oh, this is going to be exciting. I can't believe I'm about to do a blob detection from scratch tutorial. This is great. I'm very happy about this. I'm going to be very glad if this works. OK. Oops, I'm in the wrong frame. OK. Drink a little bit of this nice, delicious tea. I believe I cycled the cameras. I'm going to have this point over here to start. Move this up here. OK, now I need to save this as blob tracking. And I'm not going to do, ooh, look. My lips are a blob. OK. I think I am just ready. Someone asked, what is update pixels? Yeah, so it might work without update pixels. Processing is kind of funny in this way. My point of view on load pixels and update pixels is, first I just put them everywhere. Like if I'm about to look at the pixels, I call load pixels. If I'm about to change the pixels, like with the copy function, I call update pixels after. And then later I might try commenting out those lines and see if it still works anyway. But technically speaking, processing doesn't give you access to the memory of those pixel colors unless you first call load pixels. And it doesn't actually change them in what it draws until you call update pixels. And this is for the display window and for individual images as well. OK. Woo! Jumping jacks. I'm losing my energy. Breakdancing. OK. Yep, pull the muscle. OK, we're going to be fine. OK, here we go. The last, I think this is the last computer vision topic I will tackle today. And I'm very excited about it. And then we will do fireworks. And then I will say goodbye unfortunately, for a little bit more than a week. Don't be too sad. Trust me, there's more to life than my weird live YouTube stream thing. OK, anyway, here we go. I'm having a paranoid fear that I didn't turn this camera off and on. So I'm just going to do that very briefly. OK. Hello, welcome to yet another computer vision tutorial video. In this video, oh my God, I'm so excited. I'm going to show you how to program from scratch, not from scratch, but how to program the raw algorithm for blob detection yourself. And what do I mean by blob detection? So in 2 videos back, I made an example that finds, it's over here. No, it's over here. Where is it? OK, over here, that finds this cup that I have taped to my green screen behind me by looking for the average location of all of the red pixels it finds. And this works perfectly beautifully nicely. However, there's a problem. If I add a second cup, look at the average location is in between those 2 things. And I want to be able to track them individually as individual blobs. So how do we do that? So I want to talk about how this algorithm works. So what's going on here? There is an image that the camera is seeing. It is seeing 2 red cups taped to a wall. I don't know what my life has become that I'm taping plastic cups to walls that are painted green, but that's just what it is. Okay, so it's looking at every single pixel, and it's asking a question. Is this red? And you can insert something else there. Is this a bright pixel? Is it a dark pixel? Is it a blue pixel? You could be using a connect and depth tracking. Is it a close pixel? Is it a far pixel? There's lots of things you could substitute for this question, but for my demonstration of the algorithm, it's going to work nicely if I ask, is it red? And so the answer is going to be no. Is it red? No. Is it red? No. Is it red? No. 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 It's a very negative program. It's just no, 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 no. But eventually, at some point, it gets to over here. Is it red? And it's like, yes, yes, it's red. So if it's red, then we have to ask the question, did I find a red pixel before, or is this a new? Have I found the first red pixel? And as soon as it's found the first red pixel, it has to make a blob. So the blob is going to be a Java class, an object, which is a blob. It's going to say, I found the first red pixel, so I'm making a blob object. And I'm going to call this blob A. And blob A has an x, a y, and a width and a height. It's like a little rectangle. Now, what happens next? Oh, it goes to the next pixel. Is it red? Yes, it's red. Yes, it's red. Is it near one of the existing blobs? It is. So let's just put it in blob A, and maybe blob A gets a little wider. Then it looks for the next pixel. Oh, it's near blob A. Put it in blob A, make it a little wider. It keeps going, and then it says no, 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 no. Finds another one. Oh, it's part of blob A. No, 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 no. And eventually it gets down here and finds another bigger. Yes. Well, is it near blob A? And it suddenly realizes no. Look at that. That distance is greater than some threshold. It's time for me to make another blob. So it's looking for all the red pixels and finding the clusters of red pixels near each other within some that are far enough by some threshold amount. So that's the algorithm we need to program. And the blob I'm going to think of really just as a rectangle. It's going to have an x and a y, and it's going to have a width and a height. Okay? So let's see if we can make that happen. Here we are over here. Oh! Was I on the whiteboard? I think I was on the whiteboard that whole time. Somebody will tell me if I wasn't. Okay. That was weird. I was. Okay, anyway, I'm back. Hopefully I was on the whiteboard. Okay, so now what do I need to do? Okay, the first thing I'm going to do is I'm going to make a blob, a new tab in this processing sketch. Okay, good. And I'm going to give it an x, a y, and a width and a height. And then I need a constructor. And the constructor, when I make the first blob, it gets an x and a y. This is tricky. So the x is going to be that x, the y is going to be that y, and the width is going to be a width of 1, and the height is going to be a height of 1. Okay, great. So that's what happens when I first make the blob. Oops. Now let's think about this. So now let's go back to this algorithm. And I don't need, what do I need? I need to have some sort of variable list of blobs. So I'm going to make an array list of blob objects. Now, if array lists are new to you, it's like a flexibly sized array. So I can start with none, and I can add more, and that sort of thing. And this is something that I encourage you to look into. And one thing that I'm going to have to do, I've lost my train of thought. Okay, one thing I'm going to have to do is say blobs.clear. So this is something that's going to be really, really key, and I'm going to bring this up again later. But what this algorithm is going to do is just show me a snapshot of blobs at this moment in time, and then a snapshot of blobs at the next moment in time. But it's not going to know which blob is which over time, but I'm going to get to that in a future video. We'll talk more about that in a little bit. So I don't need this average location anymore. I don't need this count. This was all from my previous example. But what I'm doing here is what happens as soon as I find a pixel that meets this red threshold. Well, what I need to do, what I'm going to do is just say blob B is a new blob at that particular x and y. And then I'm going to say blobs.add blob B. So this is the idea. Anytime I find a pixel, I make a new blob. Only I don't always make a new blob, right? I only make a new blob. Well, when would I make a new blob? If blobs is empty, then I make a new blob, right? So if there are no blobs and I found a pixel, it has to be. Now, otherwise, and I'm going to do this in a slightly different way, but another way that I could do that is for every blob, let's add a Boolean variable saying found is false. So I want to loop through every blob and say, is one of these blobs my home? So if there are no blobs, by the way, if not found, then I add a new blob to that array list. So this is the algorithm. It's over here. I start by assuming, well, I haven't found a blob that's a home for this pixel. But now I'm going to look through all the blobs and see if one of those is a home. If after that loop, which I haven't written yet, I still haven't found one, then this pixel is a new blob. OK. So the very first thing I need to do is say, what is the distance? Or let's write it this way. If b contains or is near, let's write a function called is near. I think actually in an example that I saw, it was called that. If blob is near this particular xy point. So that's one thing I can do to check. What's the distance between this xy point and this particular blob? So let's go to the blob now and say, let's write a function that's a Boolean function. It's got to return true or false. Is near, and it gets an x. I'm going to call this like, I'll just use x underscore. I should come up with a different, somebody suggest a better variable name. But if this particular xy point is near, I need to either return true or false. So the first thing I need to do is what's the distance between xy and xy? So I'm going to call this like px for like pixel x. And let's do that up here too. I don't like this underscore thing. It looks so obnoxious. No, I don't have any, not that I have any problems with underscores. The underscores are lovely, nice characters. But I'm going to call it px for like pixel x. But actually, here's the thing. I actually want to test, I think I want to test if it's near the center of the blob, not the corner of the blob. So one thing I'm going to do is say cx for center x is x plus w divided by 2. And cy is x plus y plus h divided by 2. That's finding the center, right? X plus the width. No, that's not the center. X plus the width divided by 2. Don't be ridiculous. X plus width divided by 2. Thank you very much. Y plus height divided by 2. That's the center, right? If you have a rectangle, x plus the width of the rectangle divided by 2, that's the center location. So I want to know if that pixel is within some distance. Now, again, I could use, let's use distance squared to like not, oh, don't I have distance squared in this example? Right here. There it is. Oh, but it's only, that's a 3D distance. Let's make a 2D version of it. I have this from a previous example where I was using color. By the way, did you know in Java, you can just have a function with the same name? As long as it's two different arguments, two different sets of arguments, it'll know which one to call. That's called method overloading. OK, so I'm going to go back here. And I'm going to say if the distance is less than some particular threshold. I don't know what's a good distance. Let's say 50 pixels away. If it's within, let's say it's within 25 pixels, then return true. And this is definitely a variable that I'm going to want to make something that I can change. Otherwise, return false. OK? So now what I'm going to do is, and all this stuff is irrelevant. This was from my previous example. So if a blob is near xy, then first what I want to do is blob add xy. I want to add that point to the blob. And then I want to say found equals true. And then I'm going to say break. Now, there's a little bit of a problem here where I probably should check all of the blobs and find like the one that it's closest to. But I'm not going to worry about that right now. I'm just going to do this loop to find, and I'm just going to find the first one. So now I need to add that xy. So here, I need to write a function add that pixel x and pixel y. So what does that do? Well, the thing that I need to change is I need to check. Ooh, this is tricky here. let's think about this for a second. I'm going to use a diagram. There's probably a smarter way I could do this. Maybe somebody in the chat or will give me a suggestion. But let's say at some point I have a blob like this. And it has an x and y, and it has a width and a height. So the first thing I need to figure out is that pixel inside this rectangle? All right. If it's inside that rectangle, I don't do anything. If it's over here, I suddenly want my rectangle to be like that. If it's over here, I suddenly want my rectangle to be like that. So you know what I think I want to change about my blob? I'm going to change something. I'm going to have the blob, instead of having x, y, w, h, I'm going to have min x, min y, max x, max y. I'm just going to keep track of the top left and bottom right corner of the blob. And actually, that allows me to have this argument be x, y. And I'm just going to say, when the blob starts, the minimum x and the minimum y, and the maximum x and the maximum y. And I could have called those bottom xy, top xy. But anyway, all of those are that. Now, when I check if it's near, now I am getting the average. So I'm going to say minimum x plus maximum x divided by 2. And minimum y plus maximum y divided by 2. The distance is still the same thing between this x, y. And then the add function is going to be easier. Because what I'm going to do is I'm going to say minimum x equals the minimum of x and minimum x. This is a processing function minimum that says if x is less than minimum x, whichever one of these is less, use that one. So I should be able to just do this. And the same thing here, like this. So I just want to get, I could have written if statements like if x is less than minimum x, then the minimum x is now x, that sort of thing. But this should do that trick. This should add the blob. OK? And then, by the way, what do I've got here? I've got everything I need to draw a rectangle. So I'm going to write a function called show. And I'm going to say stroke 0, fill 255. And I'm going to say just stroke weight 2, so I make sure it's kind of thick. And then I'm going to say rect mode corners. By the way, in processing, the rectangle mode corners allows you to specify the top left and the bottom right of a rectangle. And those are the values I have. So I'm going to say rect min x, min y, max x, max y. So I added a whole bunch. The blob does a couple things. It checks to see if a pixel is near it and can say true or false. It also can add that pixel to expand or contract its rectangle. And then it can also draw that rectangle. And now, in this particular algorithm, this is it. I think I've got everything here. If it's near, where am I? If it's near, add that point. I found it. Otherwise, add a new blob. And then at the end here, after I go through all the pixels, I should be able to go through all of the blobs and say blob.show. OK, I'm sure I missed something. But let's try running it. The variable px does not exist. Oh, right, because this is now x and y. Uh-oh, max x equals x. I have an error in the chat. Someone's telling me there's an error in the constructor. Max, thank you. OK, so this was a big error. That would have caused me a major problem. OK, here we go. Let's see what I've got here. Now, ooh, what is that craziness? Oh, look at this. It's finding zillions of little tiny blobs. Oh, look at all the little tiny blobs. Little tiny blobs. Look, find some more little tiny blobs. So I think my distance threshold needs to be a little bit bigger. 25 pixels. So that's just something I need to make a variable. So I want to make this a variable. Let's just do this right now. Oh, right, because this all the way was distance squared. So it wasn't so crazy. So I'm going to make a, so this is the color threshold. And I want to make a distance threshold. And I'm going to say that's equal to 25, just having these be the same. And first of all, this needs to be distance threshold times distance threshold. And I'm going to add a, just right now, I'm going to add key pressed function. And I'm going to say if the key equals A, then distance threshold plus plus. Else if key equals Z, and this is a really quick way for me to just adjust that, minus minus, and then print line distance threshold, just so I can modify it on the fly. Here we go. Come on, everybody. Here come the blobs. Here come the blobs. Blobs, the musical. Here. Oh, yeah, much better. So we can see here now, ta-da! Now, this is still getting multiple blobs, and I can tweak things. For example, I should probably click on the color. Look, my lips are a blob. My fingers are a blob. But you can see one thing I can do here, let's zoom into this, is I can consider blobs of a certain size to be useless. So I can, one thing I can do is say here, right? I can say if blob dot size, if b dot size is greater than 100. For example, I can only show right now blobs that have a certain size, and there is no size function, but I could write one. And I could just say, return max x minus min x times max y minus min y. Like the width and the height of the blob, so to speak. I multiply them together. And I could say, they have to be greater than 500. This would get rid of small blobs. Right. Oh, and that threshold. Yeah. I meant to, by the way. So, this is also what I can change here. Let me add this second one. And you can see how nicely this is working now. My arm is blocked. Let me go over here. And you can see what I'm getting. Now, I could still, that threshold, you can see that there's two blobs up top there. Let me make that threshold. If I keep making that threshold, there we go. Now it's just one blob. And again, I could do things like interpolate or whatever. And let's do this. And here we are. And oh boy, we have to do something. Ah, no! Ah, blobs! Blobs! I'm being eaten by the blobs. That's not what I meant to do. Come on, give me some red. I am Blob Man. Okay, anyway. Whatever, you get the point. So this, I think, stop music, Steve. So I think I've shown you the basic idea of the blob algorithm. There's, I think, a bunch of things I could improve here. One, I could make a nicer interface to kind of tweak these thresholds of color, the distance threshold. It might be nice to sort of draw the rectangle, the blob rectangle with some alpha so I could see what's behind it. One thing that's really kind of important about this to mention, I'll mention this again, is come back to me, code, is that, whoops, it's funny, it worked much better without me clicking on it. Anyway, is that there's no sense of, so by the way, this distance, that threshold should really be like 75 to start with. And let's make this let's make this less. I don't know what I'm doing here. So one of the things that's really important is, let's say you wanted to have an image follow this cup and an image follow this cup. Look, it's working beautifully right now. An image follow this cup and an image follow this cup. Like, what if I wanted to put a cat over here and a dog over here? Well, I'm not always gonna, I might, this blob is gonna be found first because of the way I'm iterating through the pixels. So this blob is always gonna be blob 0. But now this blob is gonna be blob 0. This cup, that is. It's blob 0, but it's this other cup. So these blobs there's no way, these blobs don't have ID numbers. There's no way to track them over time. However, that is something we could add. So I'm going to show you how to do that. Boy, this is working so nicely. I'm so pleased. Look, I could put Mickey Mouse ears on myself. Anyway, I'm going to go do this on my own time. You don't need to watch me do the weird stuff with the blob. But I'm going to do that in a future video. Let me say one last thing. So ultimately, if you want to do this, and I'm going to show this in another video, there are ample sets of processing libraries. There's blob detection. There's OpenCV. There's a lot of processing libraries that will do this. There's also something that I haven't implemented in this algorithm, which is actually to find the contours of this cup. I'm just finding kind of the minimum maximum area of the blob. So those types of things I would recommend thinking about, contours. And so I'm going to show you at some point how to do this stuff without writing all the code for yourself, but just use a library that does the same thing. But it is interesting to see. One thing that I think is good to see about this is a lot of the libraries are built in just to look for bright or dark blobs. And so you would have to apply some type of brightness threshold to the image first before passing it to the blob detection library, which would be fine. But custom baking it yourself, you can just like look for a specific color, like red. OK. Thank you for watching this blob detection video. I'm hoping it was useful, and I'll see you in the future computer vision videos. Goodbye. OK. Oh, yes. Oliver makes a good point, which is that I could merge. There's various optimizations I could do here, like merging the blobs if they overlap. But yes. So I think that's good for computer vision for today. Let's go look at my GitHub issue, and let's see what I made. Rainbow topics, issues, sort by thumbs up, computer vision. OK, so what did I do? Let me edit this. I did average point. Let me zoom in here so you guys can see. I did average point tracking. I did motion detection, frame differencing. And then I did blob detection algorithm. So we can see here what's on my list. I don't know if any of you want to. So this is, on my list next would be looking at a library like OpenCV for doing this, looking at some of the stuff in JavaScript to see how it works and performs. I want to show you how to like keep track of blobs over time. In addition to libraries, we should look at other tools, OpenTSPS and Community Core Vision, CCV. I should look at those. Face detection with persistence, saving faces to files is kind of an interesting thing. More stuff in the browser. Kyle McDonald has a great resource for this. So I really only scratched the surface, but you know, being here for 2 hours, I think to have done 3 solid tutorials on computer vision, I feel pretty good about that. OK. So anybody see anything that they want to type in the chat that I'm missing from this list? But actually, better yet, just go and write a comment here. Add your comment here, and I'll add it to the list. OK. So I'm just about finished for today. I'm feeling like I want to do the fireworks thing. I have a question for you guys in the chat. So let me open up my fireworks example. Fireworks. Here it is. So this is the example. And so, and I'm going to also open up maybe examples, topics, under simulate, I think, simple particle system. Woo. Oh, I messed something up. I got to fix this. Ooh. I gotta file quickly. I gotta file a GitHub issue on processing. Or actually, somebody watching file this. Go to processing.docs, and I was replacing a lot of get functions. Get with vectors changed to copy. So this used to be get, but I changed it by accident to copy, but it's calling get from the array list and it shouldn't be. So I need to go through the examples and revert some of them back. Somebody file that in processing.docs, at Schiffman me and your drift, or better yet, just do a pull request to the example. But I will fix that later. But OK, so I have a question for you guys, which is I have two ways I could do this. One is I could, from scratch, from nothing, I think I could do this in a half an hour or less, make this fireworks example from scratch. The other option is I could take an existing particle system example and adapt, like this one, and adapt it to be the fireworks. So I wouldn't be doing all the code from scratch. I I don't know which would be more useful. Certainly I would do it the adapt way, but I wonder if there will be people who might actually just sort of end up at this fireworks video from nowhere, and actually having the whole thing might be useful. Let me know in the chat what you think. Boy, you guys in the chat are really quite far behind me. To make your own particle system. So to do it from scratch, Scratch, 2 votes for Scratch. Scratch, 3 votes for Scratch. All right. Scratch, yeah, Scratch. Yeah, Scratch. Okay. Scratch would be nice. Scratch would be, oh, everybody. Okay, we're going to do it from scratch. That's good to see. Okay. So don't save that. The other question is, should I do this in JavaScript? I think I'm going to do this in processing, because then I can extend it into 3D more easily. And then I'll make a JavaScript port of it. Yes, Scratch. I'm going to do it from scratch. Hopefully, I'm going to make a JavaScript port of it. Keep me honest about this, bother me about this, because I think it'll be nice to have people make their JavaScript, P5.js, Fireworks things in the browser for 4th of July. Oh, everybody now there's voting for P5.js. Maybe I should do it. Oh, I have an idea. I'll do it from scratch in P5.js because, yeah, I'm not going to do it in Scratch, so that's a great idea. I'll do it from scratch in P5.js since I already have the processing example done. And then what I'll do is I'll come back to the processing example and extend it to 3D. Oliver always has the best suggestions. OK, how about I do it in Scratch, and I'll do it in C#, which I've never used before in my life, or Python, which I just don't know at all. OK. Let me just coding rainbow, coding challenge fireworks. OK, so I need to get set up for a second. Did you guys hear that? Something fell behind me. Super shape test. That was using recent P5. Where is that? Coding rainbow, super shape test. Here it is. And I'm going to call this coding challenge fireworks P5. And I want to open that with the Atom editor. I'm going to erase everything here. And I'm going to do create canvas. Function setup. And I'm just going to give myself a little bit of something to start with. And then one thing I'm going to do, just I think it's OK for me to start with the files. I know I'm going to need a particle.js file, and I'm going to need a firework.js file. OK. And then in index, I want to make sure I am referencing particle and firework. OK. And then I need CD desktop, CD coding rainbow, CD coding rainbow, run a local server, and minimize. Camera goes off. Localhost, turn those back on. OK, and where am I? Fireworks. Okay, one thing I don't want to forget is to reference a source of inspiration for me for this project is Seb Lee Fireworks. I forget what it's called. Pixel Pyros. So if you're not familiar with this project, oh, you can hear the sound. I was gonna. So this is a project by Seb Lee Delisle. Did I pronounce his name right? Seb, friend of mine, wonderful guy, a host of the Creative Coding Podcast. Subscribe and support the Creative Coding Podcast on Patreon. Seb created a project which is, I believe he used open frameworks and lasers and computer vision, all sorts of stuff we've been talking about to create this this crazy sort of like fireworks, asteroids kind of crazy game that happens outside. Take a look at the project. I'm going to do, you can see, the kind of little bits of similarity here. I'm going to do a, quite a simplified version of this. You can see there's a lot more thought in terms of the graphics, the design, the trails, all that sort of stuff. But anyway, so I'd encourage you to check out that. It's a wonderful project. I just wanted to mention that as a kind of like where I took sort of like the visual idea for making this from. Okay. Now let's see here. So I can close that. And I think I am just about ready now. Index close, so sketch, particle, and firework. Okay. All right. Are you ready? And a 1, and a 2. Hold on, I need to give myself some energy here. Okay, it is time for
cutting random, cutting power, cutting power, cutting power, cutting power.
Okay, I'll stop doing that now. Okay, now we are ready to go. Oh, I'm feeling a little bit dizzy and lightheaded from that. Oh, okay. Ooh, it's very hot in here. Let me turn this fan on for a second. And now it's time for fireworks. Okay. All right, I'm stopping using myself with my own entertainment value. And, oh, I'm dizzy again. Everything's gonna be fine. Okay, I'm gonna start this now. Okay, let's see. Let me run this. Actually, one thing I want to do is let me just do this. Let's try this. Ooh, hold on, I'm going to fix my processing example to be, yeah, it's silly to have the background 51. It should be 0, and let's give them, this should do the trick. There we go. Okay, I think I'm ready now. Fireworks. Okay. You guys, everyone's asking personal questions about me in the chat. I guess I can marry. I am married. I do have 2 children. They are 4 and 7 years old. Actually, 8 years old now, and almost 5. Okay. Here we go. I am ready. I'm going to do fireworks coding challenge. Did I recently cycle the camera? I'm just going to do it again. I don't think I'm going to need I don't think I'm going to use the whiteboard at all for this. So, okay. Okay, here we go. Oh. Let me just fix one more thing. Sorry, everybody. I'm going to get to this now. Just fix this camera. Ah, come on, camera. There we go. Okay. Last thing I'm going to do today, coding challenge, fireworks, happy 4th of July. It's been 2 hours and 20 minutes. This should take about a half an hour or less, and then I will be saying goodbye for a while, but that sort of thing. Okay. Here we go. Hello. Happy 4th of July, if that is a holiday that you celebrate for, never mind, forget about that. It's too, I'll just do fireworks. I don't care about the 4th. I mean, it's a nice holiday, fine, whatever. But we are a global community, and I don't need to be so focused on holidays specific. This is just a fireworks video. Hello, and welcome to another coding challenge. I wanted to put a sound effect there, but I don't have my sound effects up. Forget it. Okay, here we go. I'm really doing it this time. Hello, and welcome to another coding challenge. In this coding challenge, I'm going to program a firework simulation. Pew, 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 pew. I will try not to make ridiculous sound effects during it. Let me just start. I like doing that, but I don't. Okay, let's start over one more time. You know what? Just hold on. I think they should happen a little more often. Okay, last time. Hello, and welcome to another coding challenge. In this coding challenge, I'm going to program a fireworks simulation. Pew, pew, bing. And I'm going to program it from scratch in JavaScript in the browser. The version that's running actually behind me is a version that I've made in processing, a Java-based platform. The code for the one behind me and the one that I will make in this video will both be available in links in the description. And at the end of this video, I'm hoping to return back to this processing one and also turn it into 3D fireworks. This might have a three-dimensional-like quality to it, but it's really just 2 dimensions. Okay, so here we go. So let me minimize this code, which was the processing version, get rid of that. And I have a blank JavaScript HTML5 canvas, and I have some JavaScript code. So the first thing that I need to do is I need to have, I want to have this idea of a particle. I need to have a particle. So I'm going to just write a particle a constructor function where, oh, you know what I'm going to do? Is I'm going to, the particle should have a position, which will be a vector. The particle, well, I need to use physics here, is going to have a velocity, which will right now be just 0. And the particle is also going to have an acceleration. So I'm going to kind of custom bake a physics engine. This is the same sort of model that I use in all my nature of code tutorials and videos about physics. But I'm just going to kind of bake this from scratch really quickly. And then I'm going to add a function called update. And that function does what? It takes the velocity and adds it to the position. And it takes the acceleration and adds it to the velocity. Now, where does it get acceleration? Well, I need to have a function. I'm going to call it apply force. And in that function, I'm going to get some sort of force. And I'm going to add that force to the acceleration. This is the idea of force accumulation. Force equals mass times acceleration, or force equals mass times acceleration, or acceleration equals force divided by mass. But I'm going to eliminate mass for simplicity, so acceleration equals force, or all of the forces of a moment added together. So once I do that, I also need to make sure that after I update the particle, each frame, that I multiply its acceleration by 0 to sort of clear it out, because the acceleration at each moment in time is going to start with 0. OK, so now I'm kind of got this. But the last thing I need to do with this particle is I need to have a function. I'm going to call it show, which draws, just for simplicity, just draws the particle at makes it as a point, this dot position dot x and this dot position dot y. And what I'm going to do, just for one thing I learned recently about P5.js, which by the time you watch this video in the future may not really be the case anymore, but if I set the stroke and the stroke weight up just in setup and don't set it over and over again, it sometimes can run a lot faster. So just to test that things are working, I'm going to make a variable called a firework. And I'm going to say that firework is a new particle which lives in the center of the window. And I'm going to say here in background, firework, in draw, I'm going to say firework.update and firework.show. So I want to now go back to my sketch and see, I have some errors. So particle.js, let me make this a little bit bigger. That's really big, but particle.js line number 6 has an error. Let's see, particle digest. This dot apply force equals, function is spelled with a C. Let me refresh. There we go. So you can see there's the particle in the center. Things are working so far. The next thing I want to do is let me have this particle start at a random width and all the way at the bottom of the window. And let me give that particle a velocity pointing up. So let me say its velocity is -4, pointing up. Let me run this. There we go. We can see it's going up. Each time I refresh it, it starts at a new random location and starts going up. So we're getting somewhere. The next thing that I want to do is see if I can add some gravity. So I'm going to make gravity a global variable, and it's going to be a vector that does what? It points down. So pointing down is positive. So 0, I'm going to say 0.2. And then I'm also going to say firework.apply force, gravity. So I'm now adding gravity to that particle. So let's run this. Acceleration is not defined. Let's go back to the particle. This dot acceleration. Always forget the this. Let me refresh. It didn't make it very high, but that's sort of reasonable. So let's make the particle's velocity a lot bigger, like -10. Okay, so that's good. So we can see, so this is the start of our firework simulation. Something shooting up from the bottom, and then at some point it's going to explode and make a lot of particles. But before I could do that, what I want to have is just have a lot of things shooting up from the bottom continuously. So let's get that going. So instead of having one single firework, what I really want is to have an array of them. And actually what I want is for the firework to be its own object. So I'm going to create a firework function, and a constructor function. And the first thing I'm going to do is it's going to have a local variable, which is, so I'm basically going to do what I did here, right? I want it to have in this firework object, I want it to have a particle. It's going to have that particle. The firework itself can have an update function. And whoops, what happens in the update function? It does all these things. It adds gravity and updates that firework. And then I'm going to also have a show function for the firework object. And I can see I have a syntax error, which I'm going to fix in a second. So the idea here is the particle, right? A particle is an individual particle. This firework object right now is one particle. But the firework object is also going to, in a moment, not just be the particle moving up, but suddenly all the particles that explode from it. So I need this object to keep track of that individual particle and then also an array of particles. But this should at least get me now, if I say firework.push new firework, and then I should be able to say fireworks should be an array. Then I should be able to say, look at all of the fireworks dot a length I++. And I could use a for each loop, but I'm choosing not to just for clarity. Update fireworks index I dot show. Okay, here we go. So now, okay, firework is not defined in line 6. Yep, I need the, as always, I always forget the this dot, this dot, this dot. I'm going to do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody composed that song for me. And run this again. There you can see, okay, so it happened. And now what I'm going to do is I have this line of code that puts a new firework object in the array. And I could put that line of code in draw. And if I put it in draw over and over and over again, it's just making these fireworks, making these fireworks. I don't want to make them that often. So I am going to say if random1 is less than 0.1. So every frame, there is a 10% chance of making a new firework. Let's try that. That's a little bit better. So it's making them kind of randomly every so often. So that's a good start. And now what I also want to do is, I think this should be a random value. So let's say random between -15 and -5. So that way, they don't all go on. And so that the range might be off there. Let me make the range a little bit calmer. Let's do this. So anyway, you get the idea that they're also not all going to just go up to exactly the same height. So now we're pretty good. We've got our system of the fireworks going up over time, but I need to figure out what's the point where I want them to go poof and explode into a bunch of particles. Okay, so how do I do that? Here in the update function, one thing I should edit point, timeout. I have to blow my nose. Maybe this. Okay, I'm looking at the chat. Okay. Okay. Back. What I need to do is I want to check. Something I could do is I say, how do I know when the firework gets to the top point? Well, its velocity is negative. Its velocity is negative. Its velocity is negative in the y direction. Now it's 0. Now it's positive. Now it's positive. I want it to explode the moment it reaches that top point. So I can say if this dot firework dot velocity is pointing down is greater than 0, is greater than or equal to 0, this is the moment where I want it to explode. So what I'm actually going to do is I'm going to say this dot firework equals null. So I'm just going to like set the firework to null so that it's like that will make it disappear essentially. So in the and I'm going to need some like I'm going to have to say if this dot firework. So I only want to apply force and update it if it exists, and I also only want to show it if it exists. So let's just see. There's lots of other ways I could do this, but this is just going to be a sort of way of me tracking. I could have actually a Boolean variable like exploded or something. I might change it to that later, but let's see how this works. So, that's weird. If this, that's if the y component of the velocity, right? If the y component of the velocity. Let's add that. Ooh, cannot read velocity of null. Where did that happen? Okay, well, this is an issue. So this little bit can go inside here, like also as long as it exists. There, you can see now it's disappearing the moment it kind of gets to the top. So that's good. And what I want is when it gets to the top, I want it to just go into a whole bunch of particles. So I actually kind of feel like I'm going to just change this I'm going to say this dot exploded is false. As long as not this dot exploded, apply force if it's then say this dot exploded equals false. Because as long as this, as long as not this dot exploded. I think I would prefer to use a Boolean variable if it equals true. So this should be the same exact result, but I'm not doing this sort of null thing. Okay, so I used a Boolean variable to track when it's exploded. Now, what do I do when it explodes? Well, what I need to do is I need to suddenly, right here, I'm going to just say this dot explode. So I want to put this in a separate function. And I'm going to write a function now called this dot explode. And what do I need to do in this function? I need to make a whole lot of particles. Let's make 100 of them. So for var I equals 0, I is less than 100, I plus plus. What I need to do is say var p equals a new particle. And where should that particle start? So it's about to explode. Where should that particle start? It should start where? This dot fireworks position dot x, and this dot fireworks dot position dot y. So I need to make a whole lot of these particles, and now I need an array. The firework object, in addition to keeping track of this sort of like seed firework, should keep track of this dot particles, an array. So it has an empty array, and I am now going to say particles dot push p. Okay? Particles push p. Now, what I also then need to do is, and I'm going to just do this here, right here. What I need to do is display all those. Particles index I dot show. So, and this has to be this dot particles, and this has to be this dot particles index I dot show. So what I've added here is the moment the particle reaches the top, it makes 100 new particles, and then draws all those. So let's see what this looks like. Oops, cannot read show of undefined firework.js index 30. Oh, this should be this dot particles dot length. Because I don't want it to show non-existent particles. That array is only going to have 100 as soon as it is exploded. Let's run this again. Look at that. Oh, it made 100 particles, none of which move or do anything. Pretty weird, right? Well, first of all, why aren't they moving? Well, I forgot something. I forgot that I also should call here in update. I should also call for all of those particles, apply force gravity. And for all of those particles, I have to update them. So I need those particles to experience physics as well. Oh, look what's happening. It's making those fireworks, but they're all, why? What happens when you make a new particle? It shoots straight up. So I need to make those particles in a different way. So let's look at how I'm doing that. If I go back to the particle object, the particle is always made with a velocity that randomly points up between -12 and -8. So I could use like inheritance and have like two different kinds of particles that inherit. But I think what I'm going to do is I'll just add a third argument here, and I'll call it exploder. And I'll say if exploder, I don't like exploder. That sounds violent. I'm already using explode, I guess. I'm going to call it firework. If firework, make the velocity that way. Otherwise, make the velocity. And I'm just going to do something different. Just so what I'm going to do is I want to say p5.vector random 2D. So I'm going to have any random direction. Okay. So if that's Boolean variable is true, it's going to make it as like one of those original firework things. So let me go back to this firework object. And this particle, it needs the last argument of true. These particles, it needs the last argument as false. But in JavaScript, I can also just pass nothing in, and that variable will have the value of undefined, which will evaluate to false. So this should now, if I refresh this, we can see that I'm getting something closer. So now, why are they exploding in this perfect circle? Well, the reason why they're exploding in a perfect circle, oops, I have some old notes from a computer vision tutorial, is I'm giving them a random velocity, which is a unit vector all of length 1. So they're all going to explode out in a perfect circle. So one thing I might do is just have the lengths of those vectors be a slightly random length. And I'm not going to do this in this tutorial, but you should make heart fireworks, for example. So what if you could figure out, if I draw a heart like this from the center, vectors pointing out to the edges of a heart. So you could actually, or you could use, you've got fireworks that display letters or particular kinds of shapes. So the way that you pick those initial velocities of that explosion can really make hearts or rainbows or unicorns or whatever kind of shapes you can imagine that you might like to make. So I encourage you to do that as a kind of riff off of this. You can also notice that right now it's running really, really slow. So that's another thing we're going to have to fix. But let me just go back to here. And I am going to, where was I? Under particle. Now the other thing I want to do is I actually want to, in the particle object, I think I want to keep track of this, whether it's the original firework or the particle, because I want to like do other things that are different. So I'm going to say this. Because I also want, oh, you know what, I'm going to leave that for later. Okay, so let me fix this and say random 2D and then this dot velocity multiply by something like, I know what I'm going to do in a second. Multiply by between 2, 1, and 6. So now its magnitude is going to be scaled by some random amount. Let me run this again. Oh, okay, that didn't work. What did I not do right? Let me look at this. This dot velocity multiply, random, a random value between 1 and 6. Okay, so you can see now they're really exploding kind of like wildly. There's also too many of them, so I can't really see what's going on that well. So I'm going to go back to the sketch and make them like quite a bit less often. Okay, so there's one thing, they don't look so much like fireworks. One thing that happens with a firework is it kind of like bursts out and it like really like slows down, almost as if there's like friction or air resistance, like an immense amount of air resistance in the air. So I'm gonna add that. And a quick way I can do that is in the update function, but I only want those to be for the I'm calling the thing at the bottom the firework, for the non-firework particles. So I want to say if it's not the bottom firework particle, then I also want to say this dot velocity multiply by like 0.95. So I really want its velocity to slow down. So let's see how that looks. And let me make that a bit more extreme, just so we see that that's really working. Yeah. So you can see, that that is working. Now the other thing you notice is those fireworks, they're not fading out at all. So I really think this is where I'm going to have to lose one of my optimizations. But what I need to do is I want to have a lifespan variable, and I'm going to make that lifespan 255. And if it is, okay, I should be back now. I checked, and what was actually recording to disk, hold on, let me just, what was actually recording to disk worked, but it stopped a bit before I don't know actually where it cut out. So, I just watched the video back, and it actually cut out right here where I added this bit of code. So let me refresh this. Okay. So, so this will have to get spliced together once again. Thank you, Mathieu, who has been helping me, doing an amazing job editing these things together when this kind of stuff happens. We're just about done though, which is good. Hopefully, I'm not going to lose any more outlets or whatever. And I'm about to go right back into it, okay? Let me get the chat here going. And here we go, okay? Power, okay, lost power, but I'm back now. And where I just was is I was saying, if this is not one of the seed fireworks particles, if it's not one of the seed firework particles, let's take its velocity and multiply it by something like 8.85 so that it slows down every frame. And you can see that kind of gives it this sort of like burst out that sort of slows down and stops. Now there's sort of a funny thing happening where they're still there. And when you see a firework, it explodes and kind of like fades out. And you know, I'm not going to get too crazy with visual dressing here. You can make stuff sparkle and have trails and glow and all sorts of stuff like that. But at least add something where the fireworks fade out. So what I want to add is a variable. Oh, I already did because that's before the power ran out. I'm going to add a variable called this.lifespan equals 255. And what I'm going to do is in the update function, I'm going to say also, if it's not one of the seed ones, I want that lifespan to go down by 1. And this, maybe I want it to go down. Let's actually have it go down by 4 each frame. And what I want is for the particle to have a stroke which is its lifespan. So I want to give it some alpha. So I'm going to say if it's not the sort of seed firework, do that to the stroke. Otherwise, just have a regular stroke. And then also let's make them stroke weight 2, and we'll make those a little bit thicker. So let's see what this looks like now. Ooh, is it running really slow? No. Oh, lifespan is not defined because I need to say this.lifespan. Let's try that again. So you can see here, now this is a little bit better. Now, you know, I should fiddle with these values, like maybe this should be, you know, 0.9, and its initial values should actually be between like 2 and 10, and whoops, and over here, we can see what that looks like now. And whether this is better or worse, I don't know, but I'm gonna let you sort of like consider that on your own. But I now have the basic idea. You can see very quickly now, though, it's starting to run rather slow. So we're losing a lot of frame rate here. Why are we losing a lot of frame rate? Well, it doesn't matter whether the particles have faded out or left the screen. I'm never getting rid of them. So there's a bunch of things I need to do. Number one, I need to figure out a way of getting rid of particles. So here in this, in the fireworks system, what I need to do as I'm looping through all the particles, first of all, I actually want to loop through the list backwards because I'm going to do something where I'm going to start plucking them out of the list. And if the list is shrinking, it's contracting from the end. It works better if I'm going through it backwards and taking things off the back end. So what I'm going to do is I'm going to change this loop to say go from particles.length -1 and greater than or equal to 0 and I minus minus. Let's make sure that still works. So nothing's changed, it's still working. And what I need to do, go away, Finder. What I need to do now is say, okay, well, if this particles index I is done, then this dot particles dot splice I. So splice is a JavaScript function that deletes something from an array, and you can actually splice at I a bunch of things after it, but I just want that one particle. So if the particle is done, splice, well, how do I know if it's done? I need to write a function that says if it's done. So in particle.js, I've got another function I need to add. I'll just add it over here, this dot done. And what I'll do is I'll say if this dot lifespan is less than 0, then return true. So that lifespan, which is counting down, else return false. So let's run this. It's hard to say, oops, we have an error, particle.js line 30. Line 30 here, this dot done equals function. So now I have no way of knowing if it's actually removing the particles. It does seem to be like performing a bit better, like not slowing down. So those particles are being deleted. But they're actually still a Firework object, the system object in that list. So what I want to do now is add over in the Firework object also a function that says this dot done. And how do I know if that thing is done? Well, it is done if that particle is exploded and this dot particles dot length equals 0. Right? The particle system itself is done as long as it's in a state of having exploded and there are no, and all those particles have faded out. So if that's the case, I should be able to say return true. Otherwise, return false. So now I can go back to the sketch here. And what can I do here in this sketch? I also want to loop through this thing backwards. Fireworks.length -1, I is greater than or equal to 0, I minus minus. And I want to say if fireworks.length, fireworks.done, fireworks index I dot done, then fireworks splice I comma 1. So now, and what I'm going to do is I'm also going to add just, to make sure this is all working, I'm going to add console.log fireworks.length. So now we should be able to see, you can see that length is going down. So it's never going to be too many things on the screen. So performance-wise, it's going to work fine. So this now is, JavaScript canvas drawing can be a little bit slow, but you can see I've got kind of, with 100 particles per system, it's kind of running reasonably well. Now, we can make this look a little bit nicer. For example, I could add a little bit of alpha to the background, meaning have the background transition in, and we'll have each firework draw a little bit of trail. Let's see how this looks. Right? That has a little bit more firework-like quality to it. That's nice. Then, of course, I could say, well, let me give it a color mode of HSB. And I could say for each firework, each firework system is going to get its own color. So it should get a hue value is a random hue. And then, every time I make a particle, I'm going to also want, so the system gets a hue, and then I'm going to want to send that hue into, let's do that before the last argument here, into the particle object so they can use it as well. So anytime I make a new particle, even in the explode function, I also make new particles. So I'm going to say this dot hue and false. And then now in the particle object, I can add a variable to get that hue value. And then I can say stroke is the hue 255, 255, hue 255, 255 with no alpha. And now when you run this, we can see we have rainbow. Oh, how come I lost the trail? That's weird. What did I do to lose the trail? Oh, you know why I lost the trail is because I changed it to hues, the color mode to HSB. And the background is now doing something weird. So this should fix that, I think. Whoops. Look at that. I wonder if this is a bug in P5JS that we've just found. Well, I'm going to do something here, which might make things run quite a bit slow. But I'm going to just change the color mode to RGB here. And in each particle, right before the particle is drawn, I'm going to change the color mode to HSB. Let's see if that works. There we go. So that should be, I think that seems like a bug to me. It's like there should be a way to have an alpha with the HSB color mode, but now we've got it working. And you can see, there we go. So there could be a lot of finesse here, right? I could have those velocities go at an angle. I could think more thoughtfully about what the velocities of the bursting particles are. I could have a variable amount of particles. I could think more thoughtfully about the design. I could actually store a list of history of the positions to draw a trail myself. I could use like textures. I could use something called additive blending, maybe to make things appear more glow-like. But you can see here, here's the basic idea. So I encourage you to take my JavaScript code and make some improvements on it. And I want to make a 3D WebGL version of this, but before I'm ready to do that, this kind of concludes this video, but I'm just going to keep going. I'm going to go back to my processing one. I'm going to close this. I'm going to go back to my processing sketch, which is basically 100% exactly the same code that I just wrote. But it is, oh, it's doing it full screen. I forgot that. It's doing it. So one of the things about using Java in a desktop environment is I can kind of get a bit more speed out of it. So I have now this full screen application, but this is still 2D. So what I want to do with this one, and let's take off the full screen for a second just so I can kind of see it a bit more clearly. Let's make it 800 by 600. What I'm going to do here is I'm going to change this to P3D. Each particle, when it gets drawn, is a point, but I'm going to say push matrix. I need to do 3. Actually, I could just use, I'm going to do this anyway. I'm going to use translate to add that Z axis, and I'm going to say point at 0, 0. So let's just make sure this still runs. Whoops, they're all shooting off above the screen because when I made it smaller, the initial velocity should be less strong. So let me just run this again. I'll fix that again later. OK, so that's still working. Now what I want to do, though, however, is these particles, when it explodes, somewhere I create that vector, the random vector, probably in particle system, that firework object. Yes, and then it makes a new, right here, it makes a new random 2D vector. I want this to be random 3D. Let's look at that. Let's see if this works. Now, can you see anything different here? I'm not so sure you can. But technically speaking, it should be a random 3D vector. Let's see if we can now actually start to rotate the scene to see if this really works. So I'm going to add, import a library called PZCam, which I've been doing, which I can now say I can add a PZCam object. And I can say a cam equals new PZCam this, and I'm going to say 500, like I want to look at it from 500 pixels away. The other thing that I need to do is when I make the initial particles, their location, when I make that initial particle, its location should be random. PZCam makes everything relative to the center, 0, 0. So I want to look for random negative width divided by 2 to width divided by 2. And then I also want to change the bottom of the screen is now height divided by 2. So let's run this and see what happens. Ooh, PZCam. Oh, OK, hold on. PZCam is very unhappy with my Oh, clearing of the background technique. So I'm going to lose the trails. I can get those back in another way and just say background 0. Ah, I forgot about that once I have PZCam. Okay, now let's start manipulating the scene. Can you see? I'm looking at it from above now. Yeah, so you can see I need to make a lot more of these to be able to see this more easily. Let's have a lot more being added. And let's also make the stroke weight of these particles much bigger. And let's have their lifespan last a little bit longer. And let's run this. And okay, so now, and let's actually just make this full screen again, because that might help. So I want to also make the initial random velocity much bigger. And I'm going to go back and make this full screen in P3D. And let's see if we get some nice 3D fireworks here. Ooh, that I can kind of like, yeah, you can see there they are. Oh, no, no, no. Oh, yeah, they are 3D, but they're all like in one plane. So I should also probably mess with where they start. Okay, so let's mess with where they start. So this starting location is, it happens here, which is a particle, and I don't give it a Z location. It's Z, new particle, a random, okay, hold on. The new particle gets a random X, Y, and a Z, and it should have that X, Y, and Z. And so let's give it a Z random, and then let's give it a random Z, which is going to be somewhere between -300 and 300. And so I'm going to run this. Okay, now let's sort of zoom out and look. There we go. So we can see that's not, so there is some Z depth there. It's not very much. Let's make that more extreme. I'm pretty sure, did I get it? Well, should know now. Yeah. Okay, now you can see I've got 3D fireworks. So, and then you can see that I could probably do something where I have them burst out quite a bit more, and I now have them upside down. So anyway, you get the idea. You can play with this more. So I encourage you. I'm going to post in the description of this video the processing code. I'm going to clean this up a little bit, the processing code for the 3D fireworks, as well as the browser JavaScript code. I need to get rid of the full screen thing. It has to stop. As well as the, I lost everything. Ah, come on, no, come back. Fireworks. Somebody see it, fireworks P5. As well as this code, the JavaScript version of the 2D fireworks. And I hope that you will make pretty shapes out of them. I hope that you will add angles. I hope that you will think of different ways of doing this and come up with a creative take on this and post it, share it with me in the comments or on Twitter or whatever, wherever you find on the internet to share it. And I hope you enjoyed this quick coding challenge. Wasn't very quick probably, of how to program a fireworks simulation from scratch. Thanks for watching. Oh yeah, draw a quad where the ground is maybe was a great suggestion. Okay, everybody, I'm done for today. This second part of the stream is now 20 minutes. I have no idea. I think I've been doing this for about 3 hours today. 3 computer vision tutorials plus 1 4th of July fireworks coding challenge. If you have any last questions. Oh, have I used 3JS? I haven't. And 3JS would be something good, I think, to try programming this in to see how that works. I've been using the WebGL renderer of P5JS, which, but I haven't gotten as comfortable with it yet myself, and I think it's still sort of new, and there's probably bugs in it. So, probably I'm going to try to maybe see if I can get the 3D version of this working as well. Any last questions before I go? Okay, so before I leave, let me just remind you. CodingRainbow.com is the website. Make sure you are, if you want to be, that is, subscribed on YouTube. If you want to join the Slack channel discussion group, you can subscribe on Patreon. It's a crowdfunding thing, totally optional, but I'm just letting you know it's there for anyone who feels so inclined. And then also, if you want updates about when I'm going to post my next live stream, you can get an email update by signing up there. So that's codingrainbow.com. You'll be able to find all of these links. Thank you, everyone. I am going to be away next week. I will be on the internet. So you're welcome to ask me questions or make YouTube comments. And so these videos will kind of trickle in over the next week. And the next live stream will probably be something like Tuesday, July 12th, or Monday, July 11th, or Wednesday, July 13th. Somewhere around there will be my next live stream. I will do at least 4 sessions in July. I might continue the computer vision stuff or come up with other topics based on the discussion on GitHub and in the Slack. WG Bros wants a shout out, a game that WG Bros has been making at planez.io, planez.io. Go check it out. Why can't the NFC processing function accept along as an argument? So processing as a sort of simplified creative coding sketching environment stays away from longs and doubles. And if you want to use those data types, those sort of more advanced, for sort of advanced math stuff, then just use the Java system math functions with those particular data types. I was going to answer some questions on GitHub. I'm not going to do this today, but let me just see. Let's see. Let's see if this one is quick. So one thing that I'm doing is, for anything on GitHub, you can suggest topics, but you can also just ask a question. You can include your code with the question, or it can be a general question. So, oh shoot, there was another issue. Which I thought, was it this one? No. Though this is a question, but there was a question. It seems to be gone now. That was about a particular piece of code. And I edited I changed. Where did it go? Well, I can't find it now. Is it sorted by newest? Yeah. Sort by recently updated. Computer visions. No. This is, I guess, the question. Oh yeah, this is a topic. I do want to talk about this, but not today. I will. Oh well, there was a question here that I thought I was going to try to answer online. But you can ask your questions here, and I will, in live streams, do like a Q&A where I will make a quick video that answers the question here. And you can include your code, a link to your code if you can't solve a particular problem, that sort of thing, or it can just be a general question. Okay, everybody. The archive for this stream will be up at some point later today or tomorrow, I hope. And thank you for watching. I'm sorry for those of you who just joined in. I have been going for almost 3 hours at this point, so I as much as I would love to. One of these days, I would like to do, maybe for the 100th episode, I will do an 8-hour all-day session. I'm approaching episode 50 soon. But today I'm kind of out of steam, and it's almost 3, and I've got to eat something and do some other stuff this afternoon, check my email, that sort of thing. So thanks to you again for watching. I love that you are all participating and giving me feedback and watching the videos and subscribing and all that stuff. Share with your friends if people, and keep in touch. Okay, goodbye, everybody. Here we go. I'm going to. I'm signing off. This has been
Coding Rainbow.
With me,
Dan Schiefman.
Theme song is coming. This is a temporary song. I need some more music tracks to play. It is coming. Ciao, arrivederci, au revoir, sayonara, goodbye, shalom. Can I say shalom for goodbye? I don't know. Okay. Yeah, of course I can. Peace, at least, I could say. Peace is a nice sentiment. I'm sorry that I missed so many languages in my kind of Eurocentric view. I'm going to get more next time if I ever do that again. Okay, goodbye.